Hello guys, welcome back to my channel based on African motives. In this platform, we are going to focus on the question paper which was actually written in June 2019. So this is actually June 2019 that we shall at least work on the questions that we had. So we shall just quickly rush through these questions and so forth. So let's see what we have got here. So this is actually, as we can see, guys, 2.5 hours, paper one, and yeah, everything is clear, the instructions. You're supposed to read everything and understand your instructions, guys. And okay, so this paper was actually a faint, it's actually a faint paper, but we just have to try to work on it. And yeah, so we can just understand what is there. All right, so the first part we are actually given to express 12. This is 12 over 25 as a decimal fraction. So this is your item A. This is 12 over 25. All right, so you're given 12 over 25, and we are asked to express this actually as a decimal fraction. So what I'm going to do, so remember your concept, guys. Whenever you're working with a decimal, you have to divide by the denominator here. So it's actually 25 into 12, and that is impossible for us to divide. So it's going to be 0, comma. The moment we put this, we have to add a 0 here on this, since it was impossible for us to divide. So we're now having 120. So meaning to say we are now having 25 into 120, which is into 100, that is 4 times. And we are going to have a remainder of 2, that is 20 there, because remember it's 100. So we're going to have a remainder of 20, not 2, but a 20 there. So we're going to have a remainder of 20. Then we put another 0 there, and now we can divide again 25 into this 200, which is 8 times. Remember, into 100 it was 4 times, so into 200 is going to be 8. So this is going to be 0.48. So sometimes they can even ask you to express this as a percentage. As a percentage, you multiply by 100%. So you must be very, very careful with the question. Okay, like this one on question B is 2 over 5 as a percentage. So like I said, guys, this paper is faint. I'm just going to rewrite these questions. So it's 2 over 5 as a percentage. So remember, guys, as a percentage, multiply by 100%. All right, so you can do the divisions and so forth in this case. So it's 5 into 5, that is 1 into 10, that is 2 into 0 here, that is a 0 there. So you can multiply the 2 now. That is 2 times 20 here, which is going to give us 40. So that's what you're going to have. So this is going to be 40%. So that's it for this one. And C, express the decimal 0.03, that's 0.0375 as a fraction in its lowest term. So this is a common fraction in its lowest term. So guys, we have to check here the number of decimal places after the comma. How many digits do we have after the comma? That is 1, 2, 3, 4. So which means whatever that you're going to have, you're going to divide by 10,000 with 4 zeros here, 1, 2, 3, 4. And here, you just focus on this whole number that you have got, and the whole number there is 375. So you just focus with the whole number, which is 375. All right, so you can do the divisions. So you can just choose the smaller number that we can use, the smallest number that we have got here. And I'm just going to choose 25. All right, so that's 25 here, which is into 37. We are going to have 1 here. And if we are to subtract properly, 37 minus 25, so that you can get the difference, we're going to get a remainder of 12 here. So this will be 12, and 25 into 125, that is going to be 5. Remember, into 100 is 4. So into 125 is going to be 5. All right, that is by 25. And 25 into the whole of this 100, that is a 4. Into this 0, that's 0 here. Into this 0, that's a 0 there. All right, so you can reduce again. In this case, we can choose to reduce by 5 again. All right, so you can choose 5 again. That's 5 into 15, which is going to give us 3, into 40, that is 8, into 0 here, that is a 0. So it's going to be 3. So you can see we can't reduce this further. So we're going to have 3 over 80. All right, so that's what you're going to have, just like that, as a common fraction in its simplest form, or in the lowest terms. All right, so the number 2, we are now given, write down the next term in each of the following sequences. Okay, so you've got a lot of sequences. So remember, guys, I told you whenever you're dealing with a sequence, you study the sequence that you're given. So this is 1, this is 4 here, this is 9, 16, 25, 36. Okay, so if I have to cross-check here, actually what was happening was that this was actually 1 squared, which gave us this, 2 squared, 3 squared, 4 squared, and so forth. So this is 5 squared, 6 squared. So definitely the next term is from 7 squared, and 7 squared, that is a 49. All right, so the next term in this case was going to be 49. So you study the pattern that you're given, the sequence, like see what is happening. Are you adding? You have to study that. All right, so that is the concept. Let's see the B part. We are given square root of 2, square root of 3, square root of 5. So cross-checking these numbers too, we can see actually these are prime numbers. So we've got 2, 3, 5, 7. So the next prime number from 11, that is 13. So it's going to be square root of 13. Okay, on C, we are given 16. This is 16, 8, 4, 2, 1, and so forth. All right, so what was happening here, you can see that we are simply dividing these numbers here by 2. We divided this one by 2, we got 8. 8 divided by 2, we got 4. 4 divided by 2, we got 2. 2 divided by 2, we got 1. So which means the next term is 1 divided by 2, which is going to be 1 over 2 or 0.5. So you just write this, that will be our next term. As we can see, each term was being divided by 2. You divide by 2 this one, you get this. If you divide by 2, you get this. If you divide by 2, you get this. If you divide by 2, you get this. So if you divide by 2 this one here, we are going to get this, which is 1 over 2. So that was it. If you were asked to find the next term, it was going to be the next like that. You divide again 1 over 2, divide by 2, which is going to give you 1 over 4 and so forth, 1 over 8, 1 over 16, and so on. So these were the next digits that we had. So in this case, it was just 1 over 2. Then on number 3, we are given that there are 3 girls aged 12 years, 13 years, 15 years, and they share an amount of $100 in the ratio of their ages. So take note, they are sharing in the ratio of their ages, which is 12 as to 13 as to 15. So these are the ratios that they used to share the amount of money that they had, which is $100, which is the total amount here. So this is the total that you are given. So you are given a total according to the ratio, which is, according to the money, which is $100 in this case. And according to this total ratio, according to our ratio, our total ratio, in this case, we have to add these numbers. That's 12 plus 13 plus 15. And if we add this, we are going to obtain a total of 40. All right, so this total of 40 here, according to the ratio, is the one that corresponds with this 100 here. That is the total according to our ratio. So let's see the question. What are we given on the question? Calculate the amount of money that each, take note, each girl received. We are talking about each of them. This one with 12, this one with 13, and this one with 15. So you're just going to work them according to the ratio of their ages. All right. So that means the first one of 12 years is going to get according to the number of years, that is 12 over the total. Remember, you're given the total of 40 here. So it's going to be 12 over 40 multiplied by the amount that they shared, which is $100. We get the amount for this one. And thus we can just reduce here. That's by 0, 0 can cancel. 4 here, that's 1. 4 here, that's 3. And 3 times 10, which is going to give us $30. All right, so which means this one got 30. Let's move to the second one with 13 here. So it's going to be 13 over the total ratio, which is 40 times 100, just like what we did on the previous part. So you can do the same here. All right, we can reduce by 2. That's 2 by 2. That is 5. And if we multiply properly, 13 by 5 is going to give us something like 65. So this is going to be 65 over 2. And that's 2 into 6, which is 3. And 2 into 5, that is going to be 2 here. We've got into 4, that's going to be 2, and we've got a remainder of 1, which is a 0 there. So it's going to be comma 2 into 10, which is 5. And this is money, so you have 2 digits after the comma. All right, so this is going to be $32. That is the amount of the other one that has got 13 years. And what about this one with 15 years? We just do the same again. Yes, you can choose to add these two and subtract them from 100. It's fine. By adding these two, then subtract 4, since we have got the 2, and we know that if we add them together, they must give us 100. Or you can just use your ratio, 15 again, over the total of 40. Whatever that you get here, you multiply by $100. So you just have to do the same here. We reduce this one. We got 2 here. And here we got 5. And if you multiply this time 15 by 5 is going to give us something like 75. So this is going to be 75 over 2. And if we reduce properly, just like what we did on 65, we are going to have 37,5. All right, so this is going to be 37,5, and we put our 0 there to indicate the amount, and this is dollars. So that's what we got here. So these are the amounts like we are asked of each, which means we need the first one with 12 years, 13 years, 15 years, each of them, you calculate them separately like that. So that is what we actually needed here for these 3 marks there. All right. Then now number 4, we are now asked to convert the first item, which is item 1. We are given this is 4, 3, 4 base 5 to a number in base 10. All right. So guys, remember the conversion to base 10, we have to work with the powers of the base, which is our base is 5 in this case. So we have to raise these numbers in terms of the powers of the base, and you are talking of 5. So it's 5 to the power of 0 here, to the power of 1, to the power of 2, just like that. All right, so you combine your terms in this case. All right, so we are going to have 4 times the first part here. So it's 4 and 5. So it's going to be 5 to the power of 2. All right, to put this in a bracket, plus we move to the second one of 3. So it's 3 times 5 to the power of 1, like that. To put this in a bracket, plus we've got this 4. So it's going to be 4 times 5 to the power of 0, like this. All right. So that's what you're going to have. And we can just multiply these two. That's 5 squared here. 5 squared, that's 5 times 5, which is 25. All right. So you're going to have 25 times 4, which is 100. Plus here 5 to the power of 1, which is just 5 times 3, which is 15. All right, plus in this case 5 to the power of 0, which is 1 times 4, which is 4. All right, so this is, we said 15. Let's just put it this way so that it can be clear. So we said this is 15. All right, so if we add this 15 and 4, that is 19, and 19 plus 100 is going to give us 119. All right, so I think this one is actually direct, as we can see in the other one. 75 base 10 to a number in base 2. So remember, guys, from base 10, it's just a matter of dividing by the base, which is 2 throughout, and noting out the remainders in this case. All right, so you'll be having another column of remainders like that. All right, so you can just do this direct 2 into 75. That is 37, like what we got from that previous part is 37, and we've got a remainder of 1 into 74. Then 2 into 37, that is going to be into 36, which is 18 times, and we've got a remainder of 1 there. Do the same, 2 into this 18, that's a 9, we've got a remainder of 0 here. 2 into 9, that is actually 4, and we've got a remainder of 1 in this case. All right, then we move on 2 into this 4, that is a 2, and we've got a remainder of 0. All right, we move on to this 2. Is 2 into 2, this one, which is 1, and we've got remainder of 0 again. We move on by 2, which is a 0 here, and we've got remainder of 1. Okay, so these are the remainders that we obtained, and remember, you have to take them from the bottom here going upwards. So it means we are going to have 1, 0, 0 here, 1, 0. So you just take those numbers as they are. Here is 1, 0. 1, 1. All right, so these are the numbers that you're going to have in base of 2. So guys, conversion from base 10 to any base, just divide by that base, noting out your remainders, just like that. I think it's pretty clear. On B, we are now given a condition where we are asked now to add the numbers that we are given, which are in base 8. So this is 3, 7. Let me rewrite them down. This is 3, 7, 7, base 8. And this is 4, 1, 1, which is actually in base of 8 again. So remember, guys, for us to add, we just need to have the total. And your total is supposed to be less than the base. All right, so whatever that you're going to get must be less than this, which means we have to add 7 plus 1, which is 8. And as you can see, these two, they're actually the same because we've got 7 and 1, which is 8. And if it is the same, because we've got 8, we're going to divide by that base, which is this base, which is 8, which is the same here. All right, so take note, this 8 is not of the base. This 8 here is for these two, the total of 7 and 1. Then you divide now by the base. So this is the 8 for the base, so that we don't confuse. This one is for the base. Okay, so if we divide here, that's 1, a remainder of 0. Okay, so the remainder 1 is the one that you're going to write here, which means we are saying we've got a remainder of 0 in base of what? In base of 8, like that. All right, then what about this one? What are you going to do with this? We have to add to the next terms that we have with the next numbers, which is now we've got 1 plus 7 plus 1, which is going to give us 8 plus 1, which is 9. So as you can see, 9 is greater than 8. So you have to redo this part of dividing. And this time that's into 9, that's 1, and we've got remainder of 1. So the remainder on our answer here, and this one, we have to carry it to the next terms. All right, so let's add again and see. 1 plus 3, that's 4. 4 plus 4, that is 8. As you can see, 8, we have done this before. We divided here on 8 here, and we got 1 remainder 0. So this one is just a repetition. There's no need for you to divide again. You're just going to take from what you've done before. So you got a remainder of 0 here and 1. We have to carry 1 to the next term, add to the next term like that. So here is now 1 plus, what are we adding? There's nothing here, it's just a 0 here. So it's 1 plus 0, which is 1. We can write this number as y because they are less than 8. Remember, our answers should be less than. So this one can be written because it's less than the base. So that will be our solution or the answer there. As we can see, guys, it was just direct. All right. Number 5, which is actually part of circle geometry there. Let's just try to, okay, let me reduce this so that it can be accommodated throughout. This circle was so big, guys. Okay, let me reduce to this extent. All right, so that is what we had from this circle. And we are given in this diagram that we have A, B, C, D is a cyclic quadrilateral. So this is a cyclic quadrilateral, AB equal to AD, and AC is the diameter. And okay, that is the most important part, that this one is the diameter, this A to C. Okay, and remember also, guys, what a diameter does, that it does, it subtends an angle of what? Of 90 degrees at the circumference of the circle. So you're going to see this diameter here subtending or creating an angle of 90 here. We are going to have 90 degrees at the circumference, also 90 degrees at the circumference here. All right, so that's what our theorem says about the diameter, guys. Remember, a diameter subtends an angle of 90 degrees at the circumference, as long this is on the circumference of the circle. All right, and there are some things that we can actually fill in, like knowing this from these sides, the equal sides, they subtend actually equal angles, and also A, B, C, I mean this A here to B here to D. This one, this triangle becomes an isosceles triangle. As you can see, base angles, they will be equal. So this will be 10 degrees. And also the other thing that we have got from the chord AB here, this chord AB, this chord here, AB is creating this angle of 10 degrees here at D. Also, it's creating an angle at C here, which is also 10 degrees. So it's just important for you to know that. And if this is 10, this is also 10 degrees. Why? They have got equal chords. Remember that equal chords subtend equal angles at the circumference of the circle. So which means these two angles, they are actually equal, which is the same thing that we saw here, that we are going to see here from the chord D, C, and the chord C, B, we are going to see that this angle here and this angle here, they are going to be equal. So there are so many things, guys, that we cannot. Let us quickly rush through the question. The first is to state the special name given to the cyclic quadrilateral ABCD. Okay, that's our ABCD, this one. What is the special name that we can give to this shape here? As you can see, guys, this is a kite. Remember, a kite, that's it. All right, these two, they will be equal, and these two, they will be equal. So in this case, we are having a kite here. So this ABCD is actually a kite. All right, so that's it. And B item 1, we asked to find ACD, the angle ACD. All right, so let's cross-check our ACD from our diagram here. That's ACD. All right, we have already calculated this one. We said from what? This issue of chords, we obtained 10, we say these are 10, so this one already calculated it, 10 degrees here. All right, so this is actually 10. Then item 2, that is ADC, ADC, so we have to locate this angle, A to D to C. Already we talked about this angle, we said it's 90 degrees angle subtended by the diameter. Okay, so this one was just pretty direct, or pretty clear here. It was just direct, guys, as you can see. All right, so that's our 90 degrees there. All right, so I think this is one of the easiest questions that we ever had in psychogeometry there. All right, let's see this part on number 6. Now we are given a set from the set that we are given in this case. So this paper, guys, I'm just going to work on it. It's actually something else, as you can see. Okay, but we are just going to try to work on it. Okay, the first part is the Venn diagram shows the universal set, that is subsets P, Q, R, and this is our P here. This is our Q, and this is our set R. All right, so we are now asked in this Venn diagram to shed P complement intersection R. So we've got P complement intersection R in this case like this. Whatever that you're going to have is the union of R complement union. This is intersection again. All right, so this is intersection here. So I've got intersection Q. All right, so this is what you're going to do here. It depends with how you are actually understand this concept of what, of sets and so forth. Okay, so what I'm going to do is to work them separately, then we combine our resultants. That's what most of you guys understand. So I'm just going to do it separately here, like this. Right, is it going to be clear? I hope it is going to be clear here. Okay, so remember that this is your P, this is your Q, and this is your R. Okay, so the first part that we need P complement, which means P complement is actually not part of P, so which means we are referring to this part here, outside of P. Okay, outside of P, this is your P complement, outside of P, anything that is outside of P, like this. So this is your P complement, like this. All right, so that's it. Then whatever that you're going to have intersection R. So R is this case, we are talking of everything that is in R. This is your R here. So you're going to take this part, take this part, take this part, take this part. You close everything that is in R. That is your R like this. All right. So intersection, remember, this intersection means where we have got both. All right. So I want you to cross-check from our diagram here. Where do we have both? That is the part that has got red and blue here in this case on our diagram. So you see that the part that has got red and blue is this one, is this piece here. Let me just indicate this piece here, this piece. All right, so this is the part that we are left with, this part here that has got this part that has got red and blue. That is where your intersection is, which is this part. So on this diagram here, this part that we just indicated, now I want you to see that from our actual diagram here is this one. All right, so this is the part that we just had. So now we can indicate from our diagram, which is this part here. All right, so this is the part that we are left with, this one. All right, so that's what we have got Okay, then union, we move on to this union part. Union means we are going to combine everything, all right? Whatever that you're going to have, you are going to combine it. Okay, so let's move on and see what are we going to combine. We are going to combine this part here. All right, so which part are we combining? Let's do it aside, just like what we did this one. All right, so we are going to have our sets here. All right, so remember we said we've got P, Q, and R. So this is what we have here, P, Q here, and R. Okay, so the first part is R complement, which is not in R this time. So which means we have to close this set R here. And what is not in this set is this one. Outside of what? Of R. Outside, not inside of this. Outside, that is complement. Outside of what? Of that set. So this is your complement this one. All right, so we have indicated this part to say this part here that we can see, it's not, these elements, they are not in R. That is what it means. Okay, then after that intersection, remember we said this is both now, both with what is in Q. Okay, so what is our Q? Q means we have everything that is in Q. All right, so I'm just going to put everything in Q. This is our set Q here. It comprises of this part here, the whole of Q, shade it, the whole of Q, this one, that's the whole of Q, everything, the whole of Q like this. All right, and we said intersection means both. So which piece or which part are we going to see that has got both elements? We are going to see that has got blue, and it has got also red, because we need where there's both. We are going to see is this region here. This is the region that we are going to be left with, the region that has got the part of Q, but these two are not there. So which means we need the part of Q, which is this part of Q here. This is the part of Q. This is the part of Q. This is the part of Q, the part of Q, the part of Q. Everything in Q has to be involved. All right, like this. All right, so sorry, like that. Sorry, this piece is now going somewhere like this. So it's actually to this circle here. But remember, guys, we said the union parties we combined. So if we just combine these two here, this part that we've got, that means that is where our answer is going to be. So that is our resultant in this case. So which means at the end, you are going to obtain something of this nature as a resultant. So as you can see, guys, you combined this region to this region, you combined them together. That is union. All right, so union, you have to combine everything. After you have found your answer from the first item and the answer of the second item, you now combine them together. That is the union. But intersection, what is in both, that is your intersection part. All right, so I think this part is clear. Okay, so that was our P, whatever that we had got there, which is actually 3 marks for that. And as you can see, it's a matter of working with much questions for us to understand this. All right, number 7, convert 647 cents to dollars. So actually, guys, these are cents, and we know that cents to dollars, you just have to divide by in this case by 100. So we are going to have 647. This is 647, sorry, over 100. All right, so if we divide this part, we are going to obtain that's 3 digits, moving 2 digits to the left, which is 1 to here, which is going to be 6,47. So this will be $6,47, just like that. You divide by 100, and take note how you indicate your equivalent amount at the end. It's very, very important. We need 2 digits after the comma. All right, then B, the exchange rate for converting the United States dollars to South African rand is dollar as to 13 rand 80 cents. Okay, so this is what you're given. We are given a conversion of each dollar, United States dollar, equivalent to 13.80 rand in this case. All right, so from this conversion, we are supposed to give the equivalent of 775.90. This is 75.90 in this case. All right, so let's just finish this part first. So this is 13.80 here. All right, so what are you going to do? Remember, you just equate whatever you're given, the US dollars under the US dollars. So it's US dollar of what? of 75,90 in this case, like this. All right, which is going to give us what? What are you going to get? We do not know. So that's a more here. So what do we want? We want the equivalent in terms of rands for this amount. There's going to be this amount over that amount, 75,9. Remember, I told you guys when calculating this, 0 does not work. You just leave it like that. It does not matter. All right, so whatever that you have over 1, multiply by the amount that you're going to have. In this case, so it's over 1 here, multiply by 13. Okay, so it's going to be 13,80. All right, so it's now, guys, you and your multiplication procedure, multiply these two numbers separately. All right, so if we multiply, we are going to obtain something like 104, because these are now in rand, so we are going to obtain 1047,42. All right, so make sure that you multiply properly, ignore the commas, then multiply direct the numbers. And this 0 here, don't consider it when multiplying, just ignore this. It's just for amount, just ignore it, then multiply the numbers properly. Okay, you can get that amount the same way. All right, then solve on number 8. You're now given now to solve the simultaneous equations. Okay, this is 5x actually that you're given. All right, so remember, guys, whenever you are dealing with simultaneous equations, you have to choose which method. You are not told the method to use in this case. So you have to choose the best method that you're going to use in this case. All right, so in this case, I'm just going to use elimination by substitution method. All right, so elimination by substitution, what do I mean? I'm just going to eliminate here x. Okay, I'm going to start with x here. I'm going to just eliminate x. All right, so this is multiply by, remember this is 5, this is 3, so I have to interchange these two. All right, so here I'm going to multiply by 3 on top. In the bottom, I'm going to multiply by 5. Okay, so by doing this, what are you going to have at the end? That's 5 times 3, which is 15. So you've got 15x minus 2 times 3, which is minus 6, or in this case, which is equal to 26 times 3. And this is going to give us something like 78. All right, then we are done. On this part, we move on to 5. 5 is now multiplying this, so it's 5 times 3, which is actually 15 again, that's 15x. Then 5 times 4, that is 20. In this case, we've got 20, which is equal to 5 times this 0 here, that's a 0. All right, so how can I remove, or how can I eliminate this 15x, this x here? Because we've got x and x here, which are the same, 15x, 15x. So how can we eliminate? The signs are the same. This is a plus, this is a plus. So whenever the signs are the same, you have to subtract. All right, so you subtract second equation from the first equation. Then now we are going to have 15 minus 15, that's a 0 here, but minus 6 minus plus 20, that's minus and a plus, that's a minus here, because we've got minus and a plus. So you're going to be minus 6 y like this, minus 20 y at the end. And if we can check, the signs are the same, just add the numbers 20 plus 6, which is 26. And we take the sign that is common, which is a negative there. And all right, that's it. And 78 minus 0, that is 78. Then you can reduce this by dividing. All right, to get the exact value now of y, that is, which means our y is going to be 26 into 78. That is actually 3 times. All right, or you can just reduce stage by stage, but this is going to give you a negative 3. All right, so that's the value of y. So you've done elimination. Now the substitution part, because we said elimination by what? By substitution. So it must be the first part we have eliminated, and then the second part you substitute, which is you are substituting y is equal to minus 3. All right, so I'm just going to choose any of these two equations that I'm going to work with, and here I'm just going to take advantage of this. There's nothing more to work with here because the other side is a 0 here. So I'm just going to take the second equation, which is 3x plus 4y in this case, but we have got the value of y now, which is minus 3. So it's going to be 4 times minus 3 like this is equal to 0. Okay, so that's 3x, and we've got plus 4 times minus, which is a minus 12. 3 times, which is 12 here, is going to be a 0. Then we can transpose minus 12 to the other side of the equation so that it becomes a positive. So which means 3x is now equal to positive 12. All right, so you can divide by 3. We can divide by 3, in this case, both sides of the equation. That means we can now be left with the value of x, which is a 4. All right, so these are the values that we needed, the value of x, which is 4, and the value of y, which is minus 3. So actually, when you're dealing with simultaneous, you choose the best method that you're going to work with, but all the answers, we are going to obtain the same thing, the 3 here and the minus 4. So I want you to try and see if you're actually having the same answers, just like what we got here. All right, then on number, this is now number 9. So some of these questions are not even. I don't know how this PDF was scanned, but let us just try to work on it. The sides of a parallelogram are of length 10 centimeters by 8 centimeters. One of the interior angles of the parallelogram is 150 degrees. Calculate the area. Okay, use as much of the information given below as is necessary. So here we are just given the sides and one of the angles of the parallelogram. So what I'm going to do, let's just have a sketch of a parallelogram. How does it actually look like? And we can at least work it from there. But in future case, actually, there's no need for us to even have this sketch, but just for the basic of explanation, it can help us. So remember your parallelogram, these two sides, they will be parallel and they'll be at the same time equal, which is the same with these two sides, they'll be parallel and at the same time, they'll be equal. All right, so here we are given the dimensions, that is the length of 10 and the other one of 8. Okay, so let's just say this is our 10 centimeters, which means also this is going to be 10 centimeters, 8 centimeters here. This is going to be also 8 centimeters. Okay, then we are given just one of the angles, which is 150 degrees. Why? Are you giving one angle? That is the question now we're asking. So it's just like, this is your 150 degrees. Why are you given this? Okay, because they know that you are supposed to use the properties of parallelogram to know that, remember, these are parallel lines. So it means this angle here and this angle here, they are co-interior angle. Remember your C angles, the one, your co-interior angle, this angle and this angle, they add up to 180. So we are going to subtract this 150 degrees from 180, and this is going to give us 30 degrees. All right, which is the same thing that you're supposed to know even on these two angles. But here we just take advantage that opposite angles of a parallelogram, they are equal. These angles that are opposite, they are equal. So if this is 30, this is also 30 degrees. If this is 150, this is also 150 degrees. That's opposite angles now. All right, so looking at this shape, we can take at both here on the information that we are given. We are not given 150, we are given 30, we are given 30, we are given 30. And remember that area of a parallelogram, remember that our area is equivalent to AB sine theta. That is what you're going to have in this case. So this is AB sine theta. Okay, so that means our area is going to be A and B. These are the sides that are just creating the parallelogram that you'll be given. You can just name this to be your A and this to be your B. All right, so we are good. We got 10 and 8, so it's going to be 10 multiply by 8 multiply by, so now you're going to use the 30 because this is the one that you're given. So it's either use this one or use this one. It's one and the same thing. Even if you use 150, you must know that they have got the same angle. They've got the same decimal fraction, the 150 and the 30. So I'm going to use 30 here. So it's going to be times sine 30 degrees. All right, so that is what you're going to have in this case. So as you can see, everything is now there. So you can multiply 10 and 8 here, which is going to give us 80. Multiply by, do we have the value of sine 30? Yes, we've got here sine 30 is given as 0.5. All right, so this is going to be 0.5. All right, so you can multiply. Remember, guys, by multiplying by 0.5 is multiplying by half. So you're simply saying 80 times half, or what is half of 80? Half of 80 is what? It's 40. Okay, and this is area measured in square units. So it's going to be square centimeters. Why? These sides were given in centimeters, so it's going to be square centimeters. All right, so that is going to be your area in this case. So take note, guys, take note of this part, or this particular type of equation is very, very important. All right, then let's see. number 10 now. We are given that there's a box which contains 20 sweets, which are actually identical in shape and size. All right. And here we have got the shape, the shape and the size. That is the size that you are going to have is actually the same in size and shape. Expect the only thing that is different here, that is the color that you are given. So 8 of the sweets are yellow and the 12 one are green. Okay, so we've got 8 here, which are yellow, and we've got 12 here, which are actually green. All right, so the first part was to calculate the probability of picking a yellow sweet. Okay, so how many yellow sweets do we have? So it's just direct this one. Probability of picking a yellow is going to be how many yellow do we have from this pack? If you have to cross check, we've got 8, which are yellow. So it's going to be 8 over the total now. What is the total? Remember, you're given 20 sweets, so it's going to be 20 in this case. All right, so you can play around your probability. Reduce by 4 here, that's 2. By 4 here, that's 5. So it's going to be 2 over 5. Okay, just like that, I think this one was direct. So take note here, you picked ones, so which means you're just going to work with it with one outcome like that. Okay, but I want you to see what's happened here now on B. We are now given that 2 sweets are picked at random. Take note here, these are now 2. So whenever you've got 2, that is when now you have to think along the outcomes, your probability tree diagrams there, because now they're asking now to calculate the probability that the sweets are of the same color. That is either we are working with a condition we have got yellow and because these are 2 sweets that we have got. So we need where we have got yellow and a yellow, and we've got a green and a green. So if you can just analyze your tree diagram, there's no need even for you to do this, but just for us all to understand, I'm just going to represent this on a tree diagram. So this is what you're going to have. Remember, how many sweets, like the type of sweets that we had, there are 2. So these 2 branches representing the type of sweets that you have, the colors that you have, which is in this case is yellow and green. Okay, so this is your first choice, which is the first pick that happened here. So this is your first pick or your first choice. Then the second pick from the yellow is going to give us the same thing, the 2 branches with the yellow here and also green. The green also is going to do the same thing. It's going to give us the yellow here and the green. All right, so this is now your second pick. Okay, so this is your second pick here. All right, so let's see our outcomes before we fill in our diagram. So this is yellow, yellow here, yellow to yellow. We've got yellow to green. So this is yellow, green. We have got green to yellow. This is green to yellow. Here we've got green to green. So this is green, green. All right. Now let's fill in our information. Remember the first part we are given this part here. The first part that we had, as it is usually, you have to take back this information. Remember the number of sweets that were yellow, there were 8. So the first part you have picked out of 8 of them. So it's going to be 8 out of what? 8 out of 20 in this case. All right. And the green, there were 12. So it's going to be 12 out of 20 in this case. All right. Then later on, we are now picking again. So take note, here we are focusing with this branch of yellow, this one. So you have picked one out of these 8 that we have, which means we no longer have one. We have removed one. One is already taken. So what does it mean? We are going to be left with 7 sweets which are yellow. And also it's going to affect the total. Why? Because we have picked one. So it's going to be over 19. If it is with replacement, then they will tell you that it is with replacement, which means we are going to return that one and it's going to remain as it is. But in this case, it is without. Okay, when you just do it at random like that, which means it's just without. All right, then let's move on to the green. Since we picked yellow here, which means the green, they are still the same as they were from the previous. You are focusing with yellow here, so the green is going to remain as it was, which is 12. But what have we affected on this green? We have affected the total. So it's going to be over 19. All right. So let's move on to the green. Now we are focusing on the green part now. Okay, so on the green part, okay, what happened for this to go to this side? Okay, I actually don't know what happened here. So let me just rewrite this 12 over 19. I don't know how did it manage to jump from where it was written. It even jumping. I don't know why is this jumping like this. Okay, anyways, it's fine. Then here, let's see what later on happened. We are now on the green part. The green, we pick the green here. We pick another green. So they were 12 and now they are 11 now. So this is branch for green. That's why it has to be affected. But the yellow still remains as it was before here, which is 8. What has been affected only on yellow this time is the total. So take how you fill in your diagram, guys. It's very, very important. All right. So here we said, where do we have same color? We say the same color is here on yellow, yellow, and on this green, green. All right. So we're going to have the probability of picking yellow, yellow plus the probability of picking green, green. All right. So that's what you're going to have. So remember, from one outcome to another outcome, you add, okay? But along that part of finding this outcome of yellow, yellow, these ones, you multiply them along the branch like this, you multiply them. All right, so you're going to multiply this part here. So let me just remove. Okay, so you're going to multiply the first part of 8 over 20, multiply by 7 over 19. Okay, so it's 8 over 20 here, multiply by 7 over 19. All right, 7 over 19. That's your first part. Then you move on to green, green. The first green was 12 over 20. So this is 12 over 20 here, multiply by the second green. This is your second green, which is 11 over 19. So like I was saying, guys, if you are choosing something like, there's no need for even you to apply the tree diagram. If you are given something like this, you can actually see that the first yellow was 8, the second one, it will be 7, because you picked one, then you pick again. So if you can just you have this mentality, actually you can actually win in each and every question. But it's not wrong for you to have the tree diagram. No, it's not wrong, but you can actually work out without it. Okay, anyways, let us reduce here by 4. We are going to have 2 by 4 here. That is 5. So if we multiply 2 times 7, that is 14. So we're going to have 14 here over 5 times 19. I got something like 95. Okay. Plus, in this case, we do the same here. You can reduce by 4. That is 3. By 4 here, that is 5. So 3 here times 11, that is 33. Okay, everything over 5 times 19, which is the same thing which we got there, which is 95. All right, so these are the two outcomes that you're going to have. Then we add them together, 14 plus 33. Why? Because these denominators are the same. So you can just add your numerators. We've got 95 here, we've got 95 here. So just add the numerators direct. Okay, so if we add 14 plus 33 is going to be 47. All right, so this is going to be 47 over 95, just like that. All right, so this is what you're going to have at the end. So this is where we've got what? The same color like that. So these are some of the important parts that you need to work from and analyze what you're given. Okay. Then on this question, which is number 11, we are given circles which were being combined and combined and combined like that. All right, so the first question is to ask was to state the number of circles which are there. How many circles are here? So guys, we have to count these circles. How many are they? And so forth. So if you have to cross-check, you've got 1 here, 2, that's 3, that's 4 here, that's 5, that's 6. And we've got this one, which is in between, which is the 7th one. Okay, so there were 7. Okay, so in this case, we had 7 of them. All right. Then let's see the number of lines of symmetry that is on now B. How many lines of symmetry? So remember, the line of symmetry is whereby you divide your shape into 2 equal parts. So that it doesn't overlap even if you divide like that. Okay, like this, guys, how are we going to win here? Okay, so I'm just seeing what is the best that we can do. But if you have to cross-check, guys, what happened actually was dividing this way here. You were dividing, I don't know if it, I don't have a ruler, guys. Like if I divide it this way throughout, like to this point here is supposed to be a straight line like this. That's actually, you see that this figure here, the whole of this shape that is going to be on this side here is going to cover up this side. Okay, so that's actually a line of symmetry. And if I'm to cross-check how many conditions can I have from this part? Okay, that is the first condition. So you can have from this part here, which is 1. We can have it from this part going to this point here, passing through this point here, which is actually 2. So this one is going to pass just like that, which is 2. And we have got here from this circle here, passing this like that. Sorry for that, guys, but I hope you understand what I'm trying to explain here, which is 3. Okay, so this is 1, 2, 3, like this. Okay. After that, we can divide also this circle here using this way. We can use from this point here, from this point going this way like that. Yes, you can actually divide into 2. So these are other parts that we are using. So it's 3 here, which is now 4 at this point, and this point again like that, going to this is going to be 5. And this one is going to be 6, going like this. Yeah, like that. Oh no, it's passing through this way, but it's not supposed to pass through this point, which is going to be 6. Yeah, I think that's what we all have. This one, we took this one and took this one. So they're going to be 6 of them. All right, so that's what we're going to have. So this one is going to give us 6, the first one. These ones, they're going to be 6. If it was just a single, take note, guys, if it was just a single circle like this one is got infinity, but this one is no longer, it's a shape that is created by this. They've created a shape. So this is the shape that you are referring to. All right, then I think that was it there. So we have to move on to the other one. All right, so let's just remove all this and see if it is going to be clear. From that part. All right, so that was it there. All right, what about the order of rotational symmetry? That is what we are now given in this case. So let us cross-check how are we going to have our order of rotational symmetry here. All right, so this is how we are going to have it. To rotate, we must rotate this shape and it must remain as it is. So definitely this is 1 as it is, the shape that we are given is 1. And for it to remain as it is, we are going to rotate along this circle. So it's going to be 1 here. 2, if we rotate this side, it's going to give us the same shape. On this point, it is going to give us the same shape. At this point, it is going to give us the same shape. If we rotate it, if we rotate to this point, it is going to give us the same thing. If we rotate to this point, it is going to give us the same thing. So the order in this case was going to be 6. So there are 6 possible ways that it was going to remain as it was before. So this was going to be 6. All right. Number 12, we are now given, in this case, that's a log that we have got, given logarithm of 6 in base 10, and this is low. Whenever you're given this, it means you're in base, that is what, base 10. The base in 10 might not be given, but you must know that you're in base 10. Okay, so the first question is to evaluate log 30. So how can we have log 30 from this information? 6 and 5, how can we separate these two to give us 30? So it's actually 6 times what? 6 times 5, which gives us 30. All right. So if 6 times 5 gives us 30, we have to ask ourselves, we are multiplying these numbers, but previously what was happening with the logarithms? We're adding these logarithms. We're adding the logarithm of 5 to the logarithm of what? Of 6. So that is what happened from your laws of logarithms. The log mn gives us log m plus log n. All right, so log 6 is there. So it's just a matter of substituting now, which is 0, 7, 7, 8, 1. Take note, the log is no longer there. You are now substituting the equivalent of that log. Okay, the same with log 5, you substitute the equivalent, which is in this case is 0, 6990, like that. All right, so you have to add these numbers properly. Remember, guys, when adding these decimals, the commas must be in line. Okay, so if you add properly, you're going to obtain something like 1,47. 1,4771. All right, so make sure that you add properly there. Okay, then B, the logarithm of 1,200,000. Okay, so you need to find what is the equivalent of 1,200,000. Okay, so actually the easiest way that we could have done this was to first write this in standard form. Okay, I will explain why doing this. Okay, I want us to see something here. If we are to write this in standard form, we are going to obtain 1,2 here between 1 and 10. So it's going to be log 1,2 times 10 to the power of, how many commas actually do we, if we move so that this number becomes in between 1 and 10. So if you have to cross check, this is 1 here, 2, 3, 4, 5, 6. So we actually moved 6 commas here so that this number becomes in between 1 and 10. All right. So like I was saying, it was easier for us to write this way. Why? Because we are going to see that this can be separated because we now have A and B, just like this part here where we had 6 times 5. We separated by adding these 2. All right. So it's the same thing. We are going to separate by adding these 2. But someone is wondering, where is now 1,2? Okay, it's fine. Let us separate log 1,2 plus log of 10 to the power of 6. All right, so this is what you're going to have. We are going to have log 1,2 and the logarithm of 10 to the power of 6. All right, now let us focus on this decimal part, which is 1,2, guys. 1,2 here, it simply means 12. Remember, you ignore the comma, so it's going to be 12 over, how many decimal place do we have? We've got 1, so it's over 10. All right, so reduce this by 2, it's going to give us 6, by 2 is going to give us 5. Okay, so simply 1,2 here is same as 6 over 5. That is what it means. All right, so which means we can write this 1,2 as the logarithm of 6 here over 5. So it's going to be 6 over 5 like this, plus the logarithm of, okay, here we are not going to waste much time rewriting log 10 to the power of 6. Okay, we know that P log M from this your concept of P logarithm of M, which is going to give us the logarithm of M to the exponent of P there. So we are going to rewrite this P, drop this exponent. So it's going to be 6 log 10. 6 log 10, just like what we got here, P log M. All right, where we know that we are in base 10, and I told you guys in base 10, you must know these logarithms. Logarithm of 10, the logarithm of 100, all of these must be known. Logarithm of 10 is 1, logarithm of 100 is 2. So whenever you are given the logarithm of 10 in base of 10, this is going to give us a 1. So the whole of this part here gives us a 1. So it's going to be 6 times 1, which is actually 6. All right. So that's what you're going to have. So here we are going to obtain 6 from this part. But what about this part with log 5, log 6 minus log 5, here where we are dividing? We are going to subtract. Remember, we are dividing, so we are going to subtract the logarithm. So we are subtracting the logarithm of 6 minus the logarithm of 5. So this is what we're doing. Whatever that you got here, you have to add 6 because here we are left with 6. All right, so that's it. Logarithm of 6 is there. Logarithm of 5 is there. Where from this information that you are given, remember logarithm of 6, which was 0.7. So it's 0.781. Yeah, that was 781 minus log 5. Okay, our value of log 5 here, which is 0.6990. Okay, so it's 0.6990. Okay, so you got 0.6990. Of which the 0 part does not actually affect us that much. We just need to, okay, it's fine. Then if you use it, okay, whatever that you get, you have to add 6. Okay, so subtract these two decimals. You're going to obtain something like 0.0791 plus 6. All right. So remember, this is a decimal. So you just add the 6 to the whole number here, which is to 0 here. So 6 plus 0, that's a 6. So it is going to give us 6,0791. Okay, so that's your answer there. There is no log on this answer. You just write the equivalent of that answer. That is the case. You do not write anything about the log. You need the resultant. What is equivalent to that log. That is what you need there. All right, so that was your log 1,200,000. Okay, let's see number 13, where we are given that there's a polygon in this case, which is calculate the size of one exterior angle of an 18-sided regular polygon. Okay, this is an 18-sided regular meaning to say all the exterior angles are the same. And we know that exterior angles, they are going to give us 360 degrees. So you just have to divide by 18 because you are given the exterior, one exterior. So you divide by the number of of sides, which is the number of angles. So that's it, 18 into 36, that is 2. 18 into 0 here, that's a 0. So it's going to be 20 degrees. So that's each exterior angle was 20 degrees, just like that. All right. The number 7, calculate the sum of the interior angles of a heptagon, which is can be referred to as a heptagon, which has got what? 7 sides, which is a 7-sided polygon. Guys, the sum, we are just given, this was direct, where we know that the sum is n minus 2 times 180 degrees, whereby n is the number of sides, and how many sides we have is 7. So it's 7 minus 2. Whatever that you're going to get here, you multiply by 180 degrees. So 5 minus, that's 7 minus 2, guys, which is 5. Okay, I'm rushing. Okay, anyways, multiply by 180 degrees here. Okay, that's 5 times 0 here, that's a 0. 5 times 8 there, that is 40. So you've got a 4 here. 5 times 1, which is 5, plus this 9, which is going to be 9. So that's going to be 900 degrees. Okay, so that's the sum. There is just the sum. You're not calculating anything, just the sum. Whether it's a regular, it's an irregular, the sum does not change the formula. Okay, what is important, the regular part works on finding each interior angle or finding each exterior angle. That's where the regular part is very, very important, or being regular or being irregular. That's where it works. But when calculating this sum of interior angles, there's nothing about the regular part. You just use the formula direct. Okay, think it's direct, this one. Let's see the other part here, where we are now given the number of people, that is n, who favor a certain type of energy drink varies directly as the population size S. Okay, so we have got the number of people n varies with the type of the energy drink, which is S, which is the population size for that. It varies directly as the population size. Okay, so which is S. So remember, S, that is for your population, and N is the number of people in that population who favor a certain energy drink. Okay. So the first part on A, it was to form an equation connecting N and S. Okay, so definitely we have got our N and S here. So to connect these two, we introduce the constant part. All right, so then we have to find that constant. So which means let us do our calculation nicely here. All right, so let us introduce our constant here. So N is equal to Ks. You just introduce any constant of your choice. Then they were given that there's a population of 100 people. Only 40 people were reported to favor that type of energy drink. Okay, so what are we given? We are given the population, which is 1,000, and you said our population, it's S. So which means we are given S, which is 1,000 times the constant, and the number of people here is 40 people. Okay, so 40 people only were reported to favor that type of energy drink that was there. So let us find the value of K so that we can have our relationship. So divide by 1,000 both sides, divide by 1,000 both sides. All right, so that's it. We can have our value of K here, which is going to be what? 4 and 0 there. 4 into 4, that is 1. 4 into 100, which is 25. Okay, so our K is going to be 1 over 25. So now the relationship, because it connects only two letters, it's N and S. Take note, K is not there. So which means your K has to be substituted with what? Its numerical value, which is 1 over 25. So that means our N is going to be 1 over 25S. All right, so that's what you're going to have in this case. So that is the number of people versus the population. Okay, then on B, find the population size, which is S. from which 180 people favored that type of NH ring. Okay, we are given the number of people, which is N, and we want to calculate S. So it's just a matter of substituting now on this formula here. So what are we given? We are given N, which is this N here. So N is 180 is equal to 1 over 125 times S, which is the population. Okay, so how can we remove S? We just need to cross multiply here because this is just same as 180 over 1. So, okay, this is over 1, guys, all right? So it's going to be 180 degrees over 1. So you can cross multiply this side, multiply that side. Okay, so it's 1 times 1S, which is S is equal to 25 times 180. Okay, so you multiply 25 and 180 there, which is going to give us something like 4,500. Okay, so S is going to be 4,500. Okay, so in a population of 4,500 people, only 180 they favor that NH ring. So that was the case of this type of a question that we're given. And I think it was pretty clear also. Number 15, in a rectangle A, B, C, D, the one that we are not given, so we do not have this rectangle. So try by all means, guys, if you are not given the shape, try to draw just a sketch. Okay, just try to have a sketch so that it can actually help you to answer whatever that you are given in this case. Okay, so this is just a rectangle. I'm just going to put a rectangle here. Okay, not 2, but only 1. All right, so not 2, but only 1. So I want to remove this one. All right, so this is the rectangle that we are going to have in this case, and I'm just going to name the rectangle that we have got A, B, C, D. Okay, so this is your A, that's our B, that's our C, and that's our D here. All right, so we are given A, B is 12 centimeters, A to B here, that's 12 centimeters, all right? And B, C to B to C here is 15 centimeters, okay? So this is 15 centimeters, so it's 5, not 15, guys. This is 5 centimeters. All right, so this is 5. All right, this is 5 here. Okay, so this is 5 centimeters. Okay, so and we also know that the properties that we have, guys, are that opposite sides of a rectangle, they are the same, they are equal of length. So which means this is also going to be 12 and this is going to be also 5. All right, so the question now is to express as a common fraction tan ACD. Okay, that's tan ACD. That is from A here to C to D. Okay, let me draw a line from A to C to D. All right, it's like this. Okay, so we need this angle here, that is tan ACD, this angle here. This is the one that we need. Okay, so this is the angle that you are referring to. So remember, guys, tan from your SOHCAHTOA. Okay, this is your SOHCAHTOA here. All right, that's our SOHCAHTOA like this. Okay, and we've got tan, which is opposite over adjacent. So this one is going to be opposite over the adjacent. Okay, so according to this angle here, this is your opposite and this is your adjacent. Remember, guys, this will be right angle, right angle, right angle, right angle, like that. Okay, so this is our adjacent. We have got our 12, so it's opposite 5. And our adjacent is 12 according to this part that we have got. Okay, so that's our tan ACD, okay, as a common fraction. Then we move on to cos DAC. Okay, this is now DAC. Take note the angle that you're given is DAC. That is from D to A to C, which means this time we need this angle here. That is cos DAC, which is this one. All right, so this is the theta that you are now referring to. All right, so as we know, cos here is adjacent over hypotenuse. As we can see, according to this theta and this 90, this is our adjacent now. This becomes our adjacent. Take note, we are no longer using the opposite. The opposite was for this angle here that we're working with. It's no longer applicable. All right, so now we are referring to this angle here. So this is your, this is now your opposite, this one, it is changed, and this becomes your adjacent. Okay, but we do not have the hypotenuse, which is this part here, the longer side. So that means we have to apply our Pythagoras theorem to calculate that third side. So guys, remember your Pythagoras theorem that a squared plus b squared is equal to c squared, or you can use h squared, whatever that you are capable of. So h squared is equal to a squared plus b squared. All right, so this is a squared plus b squared, where h is the hypotenuse. So h squared is equal to a and b, which are the shorter sides, which is 5 and 12. So it's going to be 5 squared plus, in this case, this is going to be 12 squared. All right, so that's it, guys. 5 squared, that is 25. So 25 here plus 144, so it's going to be 25 plus 12 squared, which is 144. Okay, so if I add this, we are going to obtain 169 as our h squared. Okay, so you can introduce the square root both sides. So that's our h is going to be square root of 169, that is 13. All right, so this is going to be 13, or you can just use your Pythagorean triples, 5, 12, 13, 3, 4, 5, and light. So you can just find your answers direct or easier like that way. Okay, so now the hypotenuse is there, the adjacent is there. So therefore, what is our cos AC, DAC? So remember, we say this is adjacent over the hypotenuse. All right, so that's adjacent over the hypotenuse, guys. Your adjacent in this case, according to this, that's our adjacent this side, which is 5. So we are going to have 5 over the hypotenuse in this case, which we said is 13. So it's going to be 5 over 13. All right, so this is 5 over 13 like that. Okay, so that was our cos DAC. Okay, then we move on to sine BDC. Okay, so we've got sine BDC. Let's locate our angle BDC. Okay, so this time we have to make another arrangement of BDC. So I'm just going to remove this line here. Okay, guys, we know that this is 13 actually. Okay, just know that was our 13. Okay, because remember that the diagonals are actually the same. Yeah, I just want you to see what is happening so that it doesn't affect. Okay, so it's like this. Okay, so remember we said our angle is BDC here, BDC. All right, so BDC, that is from B this time. This is where our B is. From B here to D to C. All right, that's our BDC. So which means we are talking of this angle here. That's our BDC. But remember, that same diagonal that we had of 13, it still remains the same. This still remains as 13. Okay, then let's go back to the sign of the ratio of sine. That's opposite over hypotenuse in this case. Also, we've got opposite over hypotenuse. So that's what you're going to have, opposite here over the hypotenuse. Okay, so let's fill in according to this angle here. So take note, we are dealing with angle D. So according to angle D here, this is your opposite, and the hypotenuse does not change, the one that is opposite to 90 degrees. So it's going to be 5 over 13. All right, so this is going to be 5 over 13. Yeah, according to this, that's your opposite B, D, C. So it's 5 over 13, okay? That's 5 over 13. These two, they are giving us the same answer. It's because of different what? They are different angles, actually. They are giving us the same thing there. That was cos A DAC. Let's cross-check, guys, what happened on DAC. It was like this. It was like this. All right, let's just cross-check. It was like this, DAC. That was the angle here. All right, that was our DAC. Okay, it's fine. That was adjacent over the hypotenuse. Okay, so these ones are going to give us the same thing. Yeah, it's fine like that. All right, so that's it. Let's see. The other part of the question, you are given that the masses, that is now on number 16, you are given the masses of 6 bags of millimil on the shelf of a shop were as follows. So these are the masses which are on the shelf. Find the model mass. So the model mass is the one that is most occurring. So if got 12 here, 12 here, 10, 10, 10, which is appearing 3 times. So definitely that's our mode here, the one with the highest frequency. So it's 10 kg. And let's see the other part, the median mass. So the median is the one that is the middle when we arrange them. Okay, so which one is going to be the middle mass in this case? So you can just cancel these, each one. Okay, so we are going to have something like this 5 kg, and the 20 kg, the 5 kg, and the 10 kg. So as you can see, these are the two which are remaining in the middle, these two. Okay, so if you've got two elements in the middle, how do you find the middle one? So you just add the 2, that is 10 plus 10. Whatever that you get, you divide by 2. So this is going to be 20 over 2, which is 10. All right, so 20 over 2 here, which is going to give us 10 kgs. All right, so that's it. So which means the median still gives us the same value, which is in this case, that's 10 kgs. All right, then we move on to the other part, which is on C, the mean mass. So remember, mean is equivalent to the sum of terms. So we are going to add those terms over the number of terms. So this is simply for sum of, okay? So this is sum of terms over the number of terms. How many terms do we have? We have to add them. 5, 5, 5, as you can see, you've got 5, 5, 10, and 10, which are 3 of them. Okay, so it's going to be 5. You add everything, 5 plus 5. We move on to those 10. There are 3 of them, so it's 10 plus 10 plus another 10. And how many 20s do we have? We just have 120 there. All right, so you just add as they are, everything that is your sum over the number of terms. You're not asking yourself how many terms are here. From this information, we've got 1, 2, 3, 4, 5, 6. So these are the 6 terms that we given. So that is your n, the number of terms here. So they are 6. All right, so I want you to add on the top, or is on the numerator, you're going to obtain 60. If I'm not mistaken there, that's a 60 over 6, which is equal to 6 into 60, that is 10. So it's going to be 10 again. So the all these answers, they were 10 kg, 10, okay, it's like that. So under exam condition, don't be surprised to seeing something of that happening. Yes, it's fine. As long as you're doing correct calculations, then it means you're actually correct. All right, so that was it. Number 17 asks to factorize. So actually, looking at the layout of this question paper, guys, you can see that this paper was actually having a different layout. These are the questions that we expect on the question number 2, question number 3, and so forth. But these questions are being given on question number 17, just imagine. Okay, anyways, that was it. But actually, according to the layout of the paper, we know that these are supposed to be the first part. Anyways, factorize completely. So this is p squared minus 4. This is a difference of 2 squares. Here we've got p squared minus 2 squared. So remember, if we can write this in terms of a square, it means we are going to have p and 2. So it's going to be p plus 2 in this case, and another one is going to be p minus 2, like that. All right, so that's it. We are done. What about the other item? 2p squared plus 7p plus 6. Okay, this is a quadratic. And in this case, we have to do the longer way because the coefficient here is no longer 1. There's a 2 there. So this time you do the longer way of multiplying the first term to the last term. That's 2 times 6, which is 12. So you are going to obtain 12p squared. Okay, what are the factors of 12p squared that we have that we can add to obtain the middle term? And our middle term in this case is a plus 7p. We must obtain a plus 7p. So in this case, we've got 4p and 3p. All right, so if we multiply this, is 12. If we add is 7. So these are the terms that we are going to use now on our factorization. So it's going to be 2p squared. You substitute this in the middle term. So it's going to be 2p squared in this middle term here. Substitute these two terms that you have got, which is 4p and 3p. So it's going to be plus 4p plus 3p. All right, so that's what you're going to have. And the last term, you write it as it is plus 6. So as we can see, now we are given, or we now have 4 terms. So we are going to group them into 2. Then we factor out what is common for these first 2 terms, and what is common here is 2p. All right, so you can factor out 2p, that's 2p squared divided by 2p here. 2 and 2 cancel, p squared, and that's p here. Plus 4 divided by 2, and p, that's going to be a 2 here. All right. And on the last 2 terms, what is common? You can see that 3 is common here for 3p and 6. So 3 is common. 3p divided by 3, that's p. 6 here divided by 3, which is 2. Okay, so the two brackets are the same. You have to factor out that common bracket. Okay, so if we factor out p plus 2, we are going to be left with 2p plus 3, just like that. Or you just know that when these two brackets are the same, just take one bracket, then the other one gives you another bracket, or you are simply factoring out the common bracket, then you'll be left with what? With the other bracket, which is 2p plus 3, just like that, guys. Okay, that was it. Then the B part, hence or otherwise, now find the highest common factor. Okay, so hence, which means continue from there. From that information that you just got, can you continue from there? So the highest common factor has to be common throughout. Okay, so you must have a bracket which is common throughout. That is our highest common factor. Which bracket is common on this? Because here we are dealing with brackets. So I want us to cross-check between these two terms that we had, which bracket is common. Am I able to select this? Okay, let me just try to select only this. Now it's selecting everything. Now that's the problem. Okay, it has selected everything. Okay, anyways, it's fine. I'm just going to take this. But as you can see, it's this bracket here of p plus 2, this one, p plus 2 here. We also have p plus 2 here. Okay, so that was our highest common factor. It must be common throughout. So the highest common factor was going to be p plus 2. All right. So just for interest sake, maybe the question needed us to calculate the LCM. What were you going to do? Okay, if it was the LCM, it means we have to take all the brackets that are present as they are. You have to take all these brackets. So the p plus 2 here, you don't repeat. You have p plus 2 here. You have p plus 2. It's appearing once, so you don't repeat this one. So it was going to be p plus 2. Okay, we move on to this bracket of 2p plus 3. Its appear is there, so you have to include it, 2p plus 3, and also p minus 2. So every bracket has to be written, which is p minus 3. So that was LCM. If the question needed you to have the LCM, that is what you're going to do. But in this case, it was just the HCF. So the HCF is this one. This was our answer here. This is the one that we needed. All right, so yeah, I think it's pretty clear, this one also. Number 18, we are now given a right circular cone. It's got a base diameter of and the slant height and so forth. So take note, guys, your cone, how it actually looks like. So we are having a cone in this case. That's something of this nature here. I don't want it to join like what it is doing. Now it's joining. Okay, anyways, I just wanted to put dotted lines like that. Okay, now it's assuming that I want to join. Okay, so it's going to be like this here, and we are going to have something of this nature. That's our perpendicular height. All right, so I'm just going to focus with this piece here. So it's going to form a right angle triangle here. So we are given the diameter, guys, take note, we are given the diameter of 24. So you can obtain the radius, which is in this case, 24 divided by 2, which is 12 centimeters. Remember, you have to divide by 2. So we have got the radius here, which is 12 centimeters here. And the slant height, take note, the slant height is this one. This is your slant height here, which is your 15. That is your slant height. So the question now is for you to calculate the vertical height of the cone. This is the vertical height of the cone, this one. Or they can refer this as the perpendicular height. That is the vertical height, the one that meets with the base, which is the horizontal line at 90 degrees. Okay, so we need to find h. So as you can see, these properties of a cone, they just helped us to know that we are going to formulate a right angled triangle here. So it's now you and your concept of application of Pythagoras theorem and so forth, because now you have a right angle triangle. So you can apply your Pythagoras theorem, where we know that hypotenuse squared is equal to side squared plus side squared, which are the shorter sides. So take note, this is the h for the hypotenuse, not the h, this one. No. This one is just our height, but the h is for the hypotenuse that we are going to have. Why are they writing extensions? Which extensions are that one? Okay, I wonder what extensions are they writing. Okay, anyways, this is our sides. So let us substitute hypotenuse. In this case, that's 15, the longer side. So it's going to be 15 squared is equal to A and B. These are the shorter sides where we've got this perpendicular height, not hypotenuse, but the perpendicular. So this H is for the perpendicular height, and the other shorter side, which is 12. So it's going to be H squared plus 12 squared. All right, so that's it. We have to find this H, which is our vertical height. All right, so let's simplify, guys. 15 squared, that's 15 times 15, which is 225. So we are going to have 225 is equal to H squared plus 12 squared, which is 144. That's 12 times 12, which is 144. Okay, so transpose 144 to the left-hand side, and this is going to be a negative on this side because it was a positive lately. So it's going to be 225 minus 144. All right, which is equal to H squared. So let's subtract 225 minus 144, which is going to give us 81. So 81 is equal to H squared. And introduce the square root both sides, So that means our H is going to be 9 there. That is 81, which is 9 centimeters. All right, so that was it, guys. We're going to obtain 9 centimeters there as our perpendicular height, which is this height that we are given in this case, which is this H. It was going to be 9 centimeters. Okay, so I'm just going to put it on the diagram. Here we've got 9 centimeters there. All right. That was the first part. So as you can see, it's actually clear, and we just need to work as much as we can, guys, working with question papers and so forth. Okay, what about B, which is the volume of the cone? In terms, take note, the volume that you are calculating has to be in terms of pi. Your answer has to remain with pi. Okay, whereby you are given the volume of the cone. Already they gave you the formula, which is not like you are supposed to be given like that. Okay, you have to know your formulas, guys. But in this case, it was an advantage type of a question. Was already they gave us the volume in this case. Okay, the formula. So we know that our formula for the volume is going to be a third pi. So it's going to be a third. So in terms of pi, which means our answer has to remain with pi. So it's a third of pi times r squared, which is the radius in this case, which is the one that we have here. Okay, we have the radius, which is 12. Remember a diameter, so the radius here is 12. So it's going to be 12 squared. 12 squared simply means 12 times 12. Okay, times the height, which is the perpendicular. This H now is the perpendicular height, not the slant height. Is this one, the H that we obtained, this height here, which is 9, not 15. So we're going to use 9 there. All right, so you multiply this by 9. Okay, so remember we said 12 squared here gives us 144. All right, so it's like we've got 144 there, so you can even reduce the 3 into 9, that is a 3. Okay, so which means in this case, we are going to have our final volume in terms of pi. That is, we have to multiply 144 times 3. And if you multiply 144 times 3, we are going to obtain 432. If I'm not mistaken, this is going to be 432. Okay, pi. So that is it in terms of pi. And this is volume, which is measured in cubic units. So it's going to be cubic centimeters. Okay, if it was meters, then it means it's going to be cubic centimeters. Okay, so that was it, guys. Let's see another part, number 19, functions. Okay, it is given that f of x is equal to 3x squared minus 2x minus 18. So this was the expression that we are given in this case. This is a minus here. So the first equation on A is to find f of minus 4. What does f of minus 4 means? In place of x, substitute minus 4. So in this case, f of minus 4, we are going to obtain something of this nature. In place of x here, substitute minus 4. So it is going to be 3 times minus 4 squared, okay, minus 2 times x, which is minus 4 minus 8. Okay, so it's now you guys and your calculator there, simplify properly here. Minus 4 squared in minus 4 times minus 4, which is 16. All right, so it's 3 times 16 there, which is 48. Yeah, if I'm not mistaken, that's a 48 there. Minus and minus, that's a plus, which is going to be plus 8 minus 8. Okay, so if we add everything, we are going to obtain 48 at the end. All right, so that's our f of minus 4. We are simply substituting in place of x, substitute that one. Okay, then the values of x for which f of x is equal to, what does this part mean, guys, when you're given that f of x is equal to? It means this was our f of x before. This one, this is our f of x. Remember, that is what we are given previously. So they are now saying this f of x is now equal to 0. So we are simply equating this equation here to 0. That's it. You solve it. So we are going to equate that your function as it was, you equate it to 0. And our function was 3x squared. Remember, it was 3x squared minus 2x minus 8. That is what we are given. Then we equate that one to 0 like that. Okay, so that was the equation, actually the one that we were given in this case. So from this part, guys, we are supposed to solve. I don't know, we are going to use quadratic formula, factorization, or so forth. So in this case, I'm just going to use factorization. Here, multiplying the first term and the last term, we are going to obtain negative 24 x squared. All right, so that's negative 24x squared. Do you have factors that we are going to use in this case? Do you have factors that we can actually apply in this case in place of what? Minus 2x, because we want to substitute this middle term here, which is minus 2x, in place with the factors of minus 24. Okay, so let's cross-check our factors. We've got minus 6x, and in this case, we've got 4x. Okay, so if you multiply these two, it's negative 24. If we add, it's negative 2. So these are the two factors that you're going to replace in the middle term, which is, in this case, we are going to have it as 3x squared. Now substitute in this middle term, which is those terms, which is minus 6x and plus 4x. All right, so that is plus 4x in this case. Minus 8 is equal to 0. So using factors, you're actually solving an equation. So this equal to 0 must maintain, you must maintain this throughout until your final answer. All right, so as you can see, we've got 4 terms, just like what we did previously. We have to group our terms into 2. So in this case, if you are to group these terms into 2, we are going to see that 3 is common for the first part here. 3x is common. So you can factor out 3x, and that will be 3x squared divided by 3x, which is going to give us x. Yeah, that will be x there. Minus 6x and 3x is going to give us minus 2. So this will be minus 2. In this case, we have got 4 and 8. So it's going to be plus 4. All right, 4 is common, so which means we are going to be left with x minus 2, which is equal to 0 here. All right, so remember your factorization. Once these two brackets are the same, you factor it out. So you factor this bracket of x minus 2, then you'll be left with 3x plus 4. All right, so this will be 3x plus 4, just like that. All right, so this is 3x plus 4 is equal to 0 like that. So what does it mean from this bracket? Either one of these bracket is equal to 0. So that means either x minus 2 should or must give us a 0 here, or the other part that has got 3x plus 4, in this case, must give us a 0. All right, so that's it. Then you can solve transpose minus 2 to the other side of the equation. That's minus 2 is going to be a plus 2. Or in this case here, if we transpose this 4 to this side of the equation, it's going to be a negative. So 3x is going to be equal to negative 4. Divide by 3, both sides. All right, so that means here we can cancel. So our x is going to be negative 4 over 3, of which you can divide 3 into 4, that's negative 1 and a third. All right, so it's going to be negative 1 and a third, or you can just even write it like that, but these are the answers that we are going to obtain from f of x is equal to 0. So it's a function, guys. When it is equated to 0 like that, you simply have to solve the equation depending with the type of equation that you're given. Is it a quadratic? Is it a linear? Whatever equation that you have, then you solve from there. That is what it simply means. All right. Then the next question, which is actually number 20. This was number 20. Even though this part was not clear, this paper was not clear, but let's just try. So this is number 20. Solve the equations. The first equation was x to the exponent of 2 over 3, which is equal to 4. All right. So remember, guys, how do you remove the exponent, which is the power here, you just have to multiply by the inverse of this number, the inverse, which means the inverse 3 over 2. So to the inverse, you do the same here to the inverse, which is 3 over 2. So by doing this, you are simply canceling this to say they are the same. So you're going to be left with x to the power of 1, which is now equal to 4 to the power of 3 over 2. So by using the inverse, and remember any number to the power of 1 remains as it is. Now you have to apply your laws of exponents, guys. X to the exponent of a over b, which I told you guys, this one gives you the base root of x to the exponent of a, like this. Okay, so guys, I've forgotten this. It needs me to be slow. I'm becoming fast now. That is why it's doing like this. Okay, anyway, so here we are going to obtain the square root. Yes, 2. So it's supposed to be 2 here, but there's no need for you to write this 2 under the square root. Even if you just neglect it, it's fine when it is 2. But if it is 3, you have to write it. Okay, so this is the square root of 4, whatever that you're going to get here to the power of 3. All right, so that's it. So the a can be inside like this, or it can be outside, because someone might wonder, why is it the law is like this and you're writing it like that? Okay, it is the same like this way, guys. Okay, this is the same thing like this. It's just one and the same thing. You can write it like this, or you can write it like that. All right, so what is the square root of 4? Remember, square root of n number, that's a plus or minus. So you're going to have plus or minus 2, whatever that we have to the power of 3 or to the exponent of 3, which is 2 to the exponent of 3, which is 8. And remember, it's a plus or minus, so it's going to be plus or minus 8. All right, so that's what you're going to have in this case, which is plus or minus 8. That's 2 times 2 times 2 times 2, 3 times, or minus 2 times minus 2 times minus 2, 3 times. So this one is going to give us a plus 8. This one is going to give us a minus 8. That's why we're writing as what? As plus or minus 8. That is what it actually means in this case. All right. So these were the stages, guys, that you just needed. As you can see, it's a matter of working from what? From the exponent, which is the power there. And yeah, that's it. And b, what can we do? There's 2 over x minus 2, which is equal to 3 over x plus 2. So there is just a matter of cross multiplying. I think that was the easiest way that we could have done this question. This is x minus 2. The other one is x plus 2. All right, so the easiest way was just cross multiplying. This multiply to this side, and this multiplied to that side. All right, so that means we are going to have 2 multiplying x plus 2. So it's going to be bracket x plus 2 in this case. All right, that's x plus 2, which is equal to the 3 multiplying this part. So it's 3 into x minus 2. All right, so that's it, guys. Let's expand our bracket. So it's 2 times x, which is 2x, 2 times 2, which is actually 4, is equal to 3 times x, which is 3x here, 3 times minus 2, which is a negative 6. All right, so that's it. Let's just collect our like terms here. We can just choose to have avoid working with negative values. It's fine even if you do it no matter way, but I can just choose to avoid negative values. That means I'm going to start with this 4, transpose this 6, negative 6 to this side of it. Was a negative here, so it becomes a positive. So it will be positive 6, which is equal to, already here I am having 3x. Okay, this thing, it doesn't want me to write fast. It thinks like I want to combine this. That's what this software thinks. Okay, so this is going to be 3x here. All right, now let's take this 2x to the other side of the equation. It's going to be a negative. So this will be negative 2x, just like that. I have avoided working with that with negative values, but it's fine even if I did the other way. So this is going to give us 10 is equal to 3 minus 2, which is 1x, and that means x is equal to 10. Okay, so let me just explain this part, what I was trying to say here. We could have just left these values as they are on this side of the equation. Still, it was going to be fine. That means here I could have left this 2x on this side. Still, it was fine. I'm just going to have 2x like this. Now it has taken the other part now, okay? It has taken another part. Yes, 3x here. All right. So this is what we're going to have at the end, which is 2x. If I transpose this 3x to this side, then what it was going to be a negative 3x. All right, so it's negative 3x this side, which is equal to, already here, I am having a negative 6. Take note. So I'm going to write that negative 6. The 4, transpose the 4 to this side, it was a plus 4 here. So it is going to be a negative 4. All right, so let's subtract 2 minus 3, which is minus 1. So it's minus x. This is the part that I just wanted to avoid of working with these negatives. Okay, negative 6, negative 4, that is negative 10. Remember, you have got same sign, so you add the numbers, then you take the sign of the common number, the common sign, that is the sign that is common between those terms that you're given. All right, so you need to take the common sign. Then divide by negative 1. Both sides of the equation, divide by negative 1. So this can cancel. You remain with x. X always has to be positive. Okay, so this and this cancel, which is a 10. So your x is going to be 10. Okay, so just like what we got on the first part, as you can see, guys, it's actually the same thing. Our x gave us a 10, which is the same thing like what we got here. So that was it, just cross multiplying. Yeah, and it was pretty direct from that part. Okay. Let's see this graph on number 21. Okay, I don't know if it is going to be clear, but these were the values I'm just going to indicate. Here it was a 0 here, and this is 100. Which marker is the brightest one? Yep, red. Okay, let's see. So this is actually at 100, and this is 200, and so on and so on and so on. This is 300 here. This is 400. The same thing here is 100 here. Is 200 here, is 300 here. And this point crosses a 300, this point crosses a 300, like that. Okay, so that was the graph that we're given, and I hope it's, and this is a broken line. This one is actually a broken line, this one. Okay, so this one was a broken line. All the other lines, this one was a continuous. This was the only broken line. Okay, so the diagram shows linear programming region, which can be described using 3 inequalities. One of the inequalities is y is greater than or equal to 0. Y is greater than or equal to 0 definitely is the one that we are given, this one. From our x-axis. Remember, guys, in the x-axis, the equation of this line is called y is equal to 0. And as you can see, this is the part that was shaded, this region. This is the region that was shaded in this case. So the one that is unshaded is the top part. That is why you see it's greater than 0 there. Okay, so already they give us the inequality of this. What about the other question now? Write or find the other 2 inequalities shown in the graph. Okay. So which 2 of them? Okay, so let's start with the broken line first. This one that crosses here at 300 and 3. So all you need is to find the equation of the line. So finding the equation of the line there, guys, I don't know which method are you going to use. I don't know. Okay, so but I'm just going to help you on finding the points. To find the equation, I'm going to do the shorter way. Okay, so what you're going to do, you take the points which are on that line that you are asked to find the equation. So in this case, we're going to take advantage of this point at 300 in the y-axis, this one, where we know that x is equal to 0 there. So the point is going to be 0, 300. All right, so it's going to be 0, 300 in this case. Okay, so let's just write our point like this. All right, so it needs me to be slow so that it can see what I'm trying to write. Okay, so this one is 0, 300. And what about this point in the x-axis where it crosses the x-axis is 300, 0. Okay, so that one is 300. X is 300 and y is a 0 there. Okay, so this point is 0, 300. So this is your x1, this is your y1, this is your x2, this is your y2, where you're going to find the gradient, then the equation of, I don't know what you're going to do. Okay, or So from this point, like I said, you're going to use your longer method and so forth. But as for me, I'm just going to use the easier way, where I told you guys that gradient, you simply have to find the gradient where gradient is increase in y over increase in x. So increase in y from this point in the y-axis there, which is at what? Which is at 300. If we increase, we are going to decrease. This one is a decrease because we are going down here. So it's going to be a decrease like this from 300 to 0 here. That's a decrease. Okay, so our gradient, which is m, which is our gradient, remember I told you is the change in y over the change in x. So like I said, you can use points, it's fine, but as for me, I'm just going to use the graph. So it's from 300 back to 0, we are going down, so it's minus 300 here. All right, so it's minus 300 over the increase in x. From this point, you continue from that point going to x, straight to x at this point. How many units have we moved from this point to this point? It's positive 300. We are going to the positive, so it's going to be a positive. Okay, so that's it. 300 into minus 300, that's minus 1. So that's our gradient, where we know that our equation is written in the form of y is equal to mx plus c, where m is the gradient and our gradient in this case is minus 1. So y is equal to minus 1x, which is minus x. And the c is the y-intercept, where this graph here crosses the y-axis at 300. So it's going to be plus 300 like that. Okay, so I have the equation. Then I need to know the inequality. Remember, this is a broken line. So the inequality can either be a greater than or a less than, because you're given a broken line. If it is a continuous line, it's going to be less than or equal to or greater than or equal to. Okay, so in this case, it's a broken line, so it's going to be a less than. And if you are to cross-check, this is the region that was shaded here. This is the region that was shaded, which is this side here. And cross-checking on this region, we need the inequality not of this region that is shaded, no, but we need the inequality of what? The region that is not shaded, which is the region that is inside, which is this side here. And this region, as we can see, guys, is actually lesser than this. Is the bigger region, and this is the lesser region. Okay, so you can note that region from the graph. By just looking at the graph, you know this is the bigger region, this is the lesser region. All right, so which means our y in this case is going to be less than minus x plus 300. Okay, so by sight, you can see that. Okay, or you can rewrite this equation, the inequality here, from the equation here, you can rewrite as transpose the minus x to this side. So someone could have written this as is still one and the same thing. You could have written it as y plus x. If you transpose minus x to this side, it's going to be a plus. So it's y plus x is less than 300. Still, it's fine like that. So that was it. By just knowing your equation, then you can find the inequality. Okay, so that was the first line. Then we move on to this line here, which is the continuous line, this one. So if you are to cross-check this line here, we had to take points just like what we did from the previous one. And the points of advantage was this one at 0, 0 here. That was our point of advantage. Let me put it this side a little bit. Okay, so we're going to take this point where it passes through the origin. For those who want to use points, so it was going to be 0, 0 like this. That was your first point. And the second point was this one. As for me, that was the easiest point, which corresponds here with x is equal to 100 and y is 200. This one is 100, 200. So x is 100 and y is 200 like that. Okay, so using 2 points, remember you can find your equation. So I want you to find the equation and so forth and so forth. Okay, but as for me, like usual, I'm going to use the easier way, or the simplest, not the simplest part, the shorter way. Okay, I'm just going to use the shorter way. And the shorter way, just finding our gradient, which we said increase in y over increase in x. So this time I'm going to take advantage of this part here, that will be my right angle triangle, this one. All right, so increase in y, I'm going down from 200 going downwards. So that's a negative. So m, which is the gradient, is increase in y, which is 200. I'm going down, which is negative. Over increase in x, I'm going this side to the left side, from this point to the left, which is a negative. So it's going to be negative 100. All right, so that's it. So if I divide these two, I'm going to obtain 2 here. Okay, so my m here will be a 2, which is the gradient. And we said our equation is y is equal to mx plus c, where m is the gradient. So it's going to be 2x plus c, where c is the y-intercept. This line passes through the y-axis at 0 there. So it's going to be 0 there. So y is equal to 2x. All right, so I want you to use the other method using points like this and see if you're going to obtain the same equation of the line. All right, now the equation of the line is there. Where am I going to shed? That is, where am I going to, like, what is the inequality like? Or according to the shadables already, here we are just writing the inequality. So what we're asking ourselves is, where are we going to have that now? Okay, so this is what I'm going to do. I'm just going to put this way. All right, so I don't know what happened there, but let's say it didn't affect us. Okay, so according to this region, this is the region that was shaded. This is the region that was shaded here. And as we can see, that's the bigger region here, and this is lesser, guys. As you can see, these are bigger values here, and these are lesser values. So y is going to be less than or equal to 2x, all right? So y is less than or equal to 2x. So by comparing, we can see these values are less. All right, so that was our inequality, all right? Just like that. Okay, so it's very, very important, guys, for you to understand the principles of the questions that you'll be given. Okay, let me adjust this way. All right, so I think everything is there. From this part, the inequalities are there. And the other part now on B was to find the maximum value of x plus y, given that x and y are integers. Take note, these are integers that satisfy 3 inequalities. Okay, so these values, what you need is to find the values of x from this region, which is unshaded, this one, the region that is unshaded. Okay, so the point that we're supposed to take was at this point, but now here it passes through a broken line. So you're not going to take this solution, okay? So you're going to take this one at 0, 0. Yes, we're also supposed to take this one at 300, 0, but it passes through this point. So we are not going to take that point. So what are you going to do? We are going to take a point which is slightly before this 300 here, the point that is slightly before, just a whole number before, and that point, according to our scale here, it's 0. Each box is representing 10, 10, 10, and so forth. So the point that you're going to have, it will be somewhere there. At 290, it will be 290. Because this point, it passes at 300, so it will pass at 290. And also here it will pass at 290 again, if I'm not mistaken, according, but that's what we say. And this graph, guys, is not clear, but I'm just showing you what you're supposed to do. So you take a point that is slightly lesser than that, and it was supposed to be at 290, somewhere like that. I don't know according to your graph, but I think it was supposed to be 290 there. Now 190, this one will be 190 because this is 200, so it will be somewhere around 190, something like that. Okay, so that point is going to be at 190, where x is 100 and y is 190. Is it 190 or 199? So just cross check, guys. If you've got a hard copy, yeah, you can actually help us, because here we do not, this graph, like this paper was not clear. I think we can also see from that part, but yeah, I think that's what if we had exact values, that's what you're going to have. But the most important part is, what are you supposed to do there? That is the most important part. All right, so that was it. We shall see if we have got clear questions next time, so that we can explain much further. Okay, so that was it. And yeah, I think it's just direct like that. Okay, then this is now 23, expressed in standard form, guys. You see what I was saying that time. Look, the questions of standard form, where they are asking us the standard form, guys. This is actually a bad layout that we are given. It's a bad layout of a question that we are given. Anyways, let's do this together. We need the standard form. So remember, standard form is going to be between 1 and 10. So it's going to be somewhere here, 6, 1, 8. And how many commas are you going to move? That will be 1, 2, 3, 4, 5. So in this case, these are 5 commas that you're going to move. So it's 10, to the power of 5. And this one is going to be a positive y because it's a significant digit. Okay, we do the same here. We're going to move commas, which is 1 here, 2, 3, 4. So it's going to be 4, 2, 3. Okay, times 10 to the power of how many commas we remove? 1, 2, 3, 4. But it will be a negative now because this one we started with a non-significant digit, which is a 0 digit. So it's going to be a negative exponent. All right, then evaluate. It's 8 comma. This is 8,76 times 10 to the power minus 2. 7,89 times 10 to the power minus 2, leaving your answer in standard form. Okay, so there we are adding, guys. So if you're adding, we have to convert back to ordinary form. That's the easiest way. Or the advantage part that was this question is because this is minus 2 here, and this is minus 2 here. So we can factor out this times 10 to the power minus 2. It's common. So all you just need is to add these numbers together. 8 comma this and this one. You just add them together. That's 8. That was the advantage part. Yes, you can convert to ordinary form. You're going to obtain the same answer. I want you to do that method that I taught you guys. But in this case, I'm just going to use this as an advantage. 8,76 plus 7,89. This is 8, 9 here. All right, so let's add. That's 15 here. And we've got a remainder of 1 here, which is 9. Plus this, which is 16, and we have a remainder of 1 here again, which is 9. That will be 9 plus, which is 16 again. Okay, so it's going to be 16 comma. Okay, so we're going to obtain 16,65. All right, like that. But cross-checking at this number, we are going to see that the number that we are given is not in standard form because it's actually bigger than what? It's bigger than 1. Like the digit that we are having is not in the range. So we have to convert this part here to standard form. So how are we going to convert this? By moving this comma so that it becomes in between 1 and 10. So it's going to be 1,6. So it is going to be 1,665 times 10 to the exponent of minus 1, because we've just moved 1 comma. So it's going to be positive 1 because we started with a 1 digit here. So it's going to be power of 1, sorry, multiply by 10 to the power of minus 2, which was already there. Okay, I'm multiplying the base, which are the same. So what am I going to do? I'm going to add these exponents here, which is add the exponents. Okay, so if we add 1 plus minus 2. So remember, guys, plus and minus is a minus. So 1 minus 2, that's minus 1. Okay, so we are going to obtain minus 1, which is 1,665 times 10 to the power minus 1. Now it has started now to think that I want to combine this to be one thing. Okay, so not one thing, guys. This is times 10 to the power of minus 1. We said minus 1. Yes, this is minus 1. All right, so that's what you're going to have in this case. So like I said, if we had to convert this to ordinary form, it means we're going to have something like this. Okay, let's get back to our ordinary form and see if you're going to have the same thing. This was going to be 8,76, sorry for that. We move 2 commas to the left because we've got a negative here. So it's going to be 1, 2. In place of this growth, we put a 0 here. So it's going to be 0, 0. There, we are now having a 0 here. 8, 7, 6. All right, we do the same here. 7, 8, 9. Main commas to the left. 2 again, that is 1, 2. In place of this growth, you put a 0 here, so it's going to be comma here. So it's going to be plus, because we are adding. So we're going to add 0, comma. Make sure the commas are in line. So this is 0, 0, 7, 8, 9. So this is 7, 8, 9. All right. So the procedure of adding, guys, as you can see, is going to give us one and the same thing where we added here. We say this one is going to be 15. We give a 1 here. 16. We give a 1 here, which gave us, guys, this thing now, it needs me to be slow. I don't know how, if I'm going to finish now, if I'm that slow. Okay, so we said we are going to give a 1 here, which will be 1. Is that so, guys? I'm now lost. Where am I? Okay, but this was a 1 here, which gave us 16 now. Okay, so this will be a 16. We give a 1 here, yeah, which is going to be a 1. All right, and comma here, and 0 plus 0, that's a 0 here. Then you convert now this answer, because the answer, yes, you now have your answer here, but this answer is in ordinal form. So you have to convert to standard form, where we said our number has to be between 1 and 10. So you just move 1 comma so that it becomes 1 and 10. Between 1 and 9, between 1 and 10, that is 1 to 9 there. So it's going to be 1 comma 6, 6, 5. All right, so that's it. Times 10 to the power of the number of commas that we moved is just 1 comma, and it's a negative y. You had a 0 digit, so it's going to be a negative. So as you can see, we are obtaining the same answers. Someone had to convert to ordinary form, then convert back to standard form. Someone had to just work it direct in standard form, but still obtaining the same answers. That's how these questions might be like. Okay, 23. We are given the diagram shows 2 intersecting straight lines, A, O, B. So this is A, O, B. This is your A here, and that's your O, and this is your B. And this one is X, O here to Y there. This is Y here. Okay, so what you are given is that they gave us the vectors OA is equal to P, and this one is equal to Q. So these are the small vectors that you're given. This vector here is vector P, and this vector is vector Q. Okay, so also take note of the direction where it is referred to. All right, so that was your diagram, and you are given this ratio here from A to O, the ratio of A to O over OB. So let me just write it clear. This is AO over OB, which is equal to XO over OI, which is equal to 1 over 3. So I want you to take note what is happening. You are taking from A to O on the diagram, that is A to O, and O to B, that is this point, O to A, O to B, O to X, and O to Y. So it's the same thing. Is going to be from A to X and Y to B, or whatever, X to A, or that part is going to be the same. So this is the same as from X to A over the bigger one, which is B to Y. So as you can see, is the smaller side to the bigger side, smaller side to the bigger side, corresponding sides actually. So that ratio, you can actually add this part which was not there, because this is not given, but you can also add it to be part of what? To be part of that inequality, the equation that you are given, the ratio that you have. So it can help us to answer the questions. Okay, so the first part, express in terms of P and or Q. So this is vector P and or Q. Okay, the first one is vector AX. Okay, so that is our first item here, which is to find vector AX. So what I'm going to do, guys, let me just try and remove this part first. And guys, this thing of wanting me to write slowly, I don't know. I'm going to change this software. Maybe it's going to help us. I don't know, guys, if you have any other that makes me to write fast, because if I write fast, okay, anyways, that's our AX. So which route are you going to take? This is a vector from A to X here. So which means we need this route here from A to X. So from back your vector, AX is going to be from A to X. Which route are you going to take? The route has to start with A. So it's A to O. So that is the route that you're going to take, A to O. All right. Okay, so that is A to O there. So it's going to be from point A to O. Then you move from there, from point O to B, from this point O to X. So we are referring to X, so you have to go to X. So it's going to be O to X. All right, so this is the route that you're supposed to take. Okay. So now let's substitute from A to O here. You are opposing the arrow here. As you can see, the direction is going this way, and as we are now going the other direction, so you multiply by negative. So it's negative P Then from O to X, as we can see, we are maintaining the direction here from O to X. So it's going to be a plus P, okay, a plus Q, that's a Q there, okay. So that was our vector AX, or you can write it as Q minus P, it's just one and the same thing, just like that. Okay, then let's move on to another vector, which is BY, in this case, BY. Okay, so this is BY. So you can actually take it from this way, because already we have got this ratio that we talked about here. AO over OB, which is equal to this. So now remember, we have got AX here, which is AX is XA. It's actually like XA here. We can write this. Remember, we said it's one and the same thing. So remember, AX is already there. This one is your AX here. That is the relationship that you have got here, which is your XA. Like this is just a root here, but in terms of vector, you can write it as AX here. This one can be written as AX here. This is not a vector, it's just direction to say from X to A, the distance. So do not mind this part that I have written here. So you can even write it as AX over BY, which is the same part that they're asking here over BY. So it's just one and the same thing, guys, as you can see from this part. And also the other thing that helps us is to know the direction. Okay, from our parallel lines, if these two lines are parallel like this, okay, if they are parallel, they must maintain the same direction like this. They are parallel also like that. Okay, they must maintain the same direction. So it's AXB Y. So they must be like that, maintaining from A to X. As we can see, from A to X is going to be like this. From Y to B. So B to Y is going to oppose like that, but they will be parallel to each other. These two, they are actually parallel to each other. Okay, so which means in this case, we are just going to multiply according to this ratio here. All right, so which means according to this ratio, our AX over, in this case, if you are to take this AX over YB, according to this one, is going to be YB because of the direction. Okay, so it's going to be YB according to the vector now, which is going to be 1 over 3, which is from this ratio. What I just want to do is to maintain the AX, not XA, because we found AX here, guys. Take note, we found AX. So let us maintain AX. That's why I have to rewrite this. Okay, so it means from this, I can substitute and make YB to be the subject here by just cross multiplying these two. So it means 3 AX is equal to YB times 1 by cross multiplying here, which is YB. Okay, so that means our YB is going to be 3 times AX. Okay, so that is 3 times AX, which is the AX that we got here. Remember, AX is there, it's minus P plus Q. So we're going to multiply that by 3, okay, which is minus P plus Q, like that. All right, so let's multiply 3 times minus P, that is minus 3P. 3 times Q, that is going to give us 3Q like this. Okay, so this is YB, but we need BY here. So what are you just going to do? We just have to multiply by negative already. Because the direction here must be the same. As you can see, guys, the direction, like the arrows here, they must be the same, like they must face the same direction. So the YB is the one that we got, this one. Okay, then BY is going this direction, so it opposes this direction. So you just multiply by a negative. Okay, so that means our YB in this case, BY now, not YB, now it's now BY, because we need to find BY here. So it is going to be BY this time. Okay, that's it. So it's going to be BY is equal to, so this is BY, what is it happening now? Okay, so this is BY, which is just multiply this by a negative. Okay, so if you multiply everything by negative, it's going to be like this, negative 3P plus 3Q like this. All right, so this can be a positive. So it's going to be positive 3P negative 3Q. Like that. Okay, so this will be your BY now. All right, so that was it from this part. And the other part is to state any two relationships between lines AX and YB. Okay, if I want you to cross-check how they have given you. They are giving you as AX, YB, not BY. Here it was BY, but this time it's YB, which means they need this relationship here that we got here between AX and YB here, this one that we wrote here. Remember, this is your relationship between AX here and YB. This is our relationship. Okay, so what is the relationship between these two lines? Actually, we can see that YB is equal to 3 of AX. Okay, YB is equal to 3AX, or you can just write that YB is 3AX. So what can we see? It means that this YB has to be reduced by 3 to find AX, or it means we can enlarge this AX 3 times to get YB. Okay, so the relationship that we can have, first part is of enlargement. Okay, so AB is that is YB. In this case, is an enlargement. YB is an enlargement of AB, of AX, sorry, this is of AX, okay, by factor 3, okay, by factor 3. Okay, so that's an enlargement. This line, if you multiply this line, not YB, but AX, the one that you're multiplying, sorry, AX, which is AX. Okay, so sorry for that, guys. These things of working with the not referring back to your questions now. Okay, so this is AX here, and this is YB. Okay, guys, why is it now removing this? So this is our AX here, and this is our YB. I hope you understand what I'm trying to say here. I hope you're going to understand this part. This software, guys, I wonder what's happening. Okay, let me just rewrite. This is AX, and this is YB here, like this. Okay, so that's YB. So as you can see, AX here has been increased by 3 to give us what? To give us YB. Okay, that's the first part or relationship that we have. The second one, we are seeing that these are actually these two here in terms of vectors. Here we are talking of lines. Then in terms of vectors, what do we see? These are parallel lines, as you can see. So YB is parallel to AX. That can be another relationship. So this one, we are saying AX is parallel to YB. So AX is parallel, this one, parallel to YB. Okay, so these two at the same time they are parallel. So take note, guys, when you deal with the vector, direction is important. Y to B, B to Y, they are not the same. They differ in terms of the sign. The magnitude is the same, but the signs, they are going to be different. So take note. But in terms of this part, it's just common like that. Okay, so that is it. 24, we are given that Moyo village is 5 kilometers from Dube village on a bearing of 20. And Dube village is 6 kilometers away from Dube village on a bearing of 60. Okay, so we've got two families, actually 3 families that we have got here, but they are related, all of them, they are related from Dube family. Okay, so the Dube family is the one that is giving us the bearings here, like this one. I don't know the space now. The space that we have here is actually less, guys. And this thing cannot even erase something like that. Okay, or even to cut this. Let me try to create a space. If it is going to work, but if not, then we just have to work it like that, guys. Okay. Doesn't work. Okay, so it means we just have to work it like that. Okay, so this is our first part, which is our North Pole. From where we are relating, we are related from what? from the Dubé family. Okay, so the Dubé family is actually the one that is dominating for the meantime here. Okay, so from Dubé family, the first one is on a bearing of 20, which is somewhere this way. And this part is somewhere 20. Remember, this is three-figure bearing from the north in a clockwise direction. Okay, so this is where we are going to have our 20 degrees here. Okay, so that's our 20 degrees. That's the North Pole. So where are we going? We are actually going to reach the 20, which is this one, the Moyo family here, which is the Moyo village here. This is our Moyo village here. From the same Dube that we are given here, it's now giving us a bearing of 60 degrees to the Ngube village. Okay, so it's 60, it's before 90 again, but somewhere like this. Okay, so this becomes our 60. Okay, so this is 60 here, like this. So that is what we're given. So this is 60 degrees. The whole of this angle is 60 degrees there. All right, going to the Ngube family here. So this is where our Ngube family is going to be located here. That's our Ngube family with its North Pole, and the Moyo family here with its North Pole. Okay, so the first question was to find the bearing of Dube village from the Moyo village, which means from this village here. From this one, from the North Pole of Moyo here, in a clockwise direction like this, what is the bearing that we are going to have here? All right, so that was the question. So guys, as you can note that this is 20 degrees here, and this also is going to be 20 degrees from your Z angles. That is alternate angles, the one that gives us a Z. Okay, so this one is going to be 20, and this one is going to be 20. And we've got a straight line. Remember, angles on a straight line, they add up to 180 degrees. So we're going to add 180 degrees plus this 20, is it 20 or it's, yes, 20, that one. Okay, so it's going to be 180 degrees plus 20 degrees. All right, so that is going to be our bearing, which is 200 degrees. In this case, three-figure bearing, just like that. Or if you wanted the compass bearing, it was going to be south going to the west. Okay, this is your west side. So it was going to be south 20 degrees to the west. So it's south 20 degrees to the west. So this is your compass bearing. Okay, this is your three-figure bearing, just like that. Okay. So that was it from this question. Then the other part now is to find the distance from Moyo village to Ngube village, leaving your answer in said form. You are given cos 40, sin 40, and so forth and so forth. Okay, so now they need this distance here between the Moyo and what? And the Ngube, this one. This is the distance that we need in between here. So let's just call this distance x. We do not know this distance, but remember that Moyo from Dube is 5 kilometers here. So here we've got 5 kilometers. Remember that. Moyo to this one is 5 kilometers, and Ngube to Dube is 6 kilometers here. And we say this angle is 20, the whole of this angle at D is 60. So to find this angle inside our triangle at D, this angle only at D, we are going to subtract, okay? That's 60 minus 20, which is 40 degrees. Okay, so that's it, guys. As you can see, we are given two sides here, and we want to calculate the third side of a non-right angle triangle. So definitely we are going to use cosine rule of calculating the side, which states that cosine rule from our A, we know that A squared is equivalent to B squared plus C squared minus 2BC cos of what? Cos of A. All right. So in this case, the distance that we want is just going to be, just say x like what we wrote it there. So it's x squared is equal to the B and the C. These are the sides that are creating what? Creating our angle of 40 degrees here, which is got 5 and 6. All right. So that's 5 there and 6 is going to be 5 squared plus 6 squared minus 2 times 5 times 6 cos of the angle. Now, the angle that we are talking about in this case is that angle that is in between these two sides, which is 40 degrees, as we saw from our diagram here. This is the angle that we're talking about in between, which is 40 degrees. All right, so it's going to be cos 40 degrees. So that will be our distance here. But remember, this distance is needed in set form. That means under the square root. Here, we must leave our answer under the square root. Leave your answer in set form. All right, so let's substitute whatever that we have, simplify whatever that we have. So x squared is equivalent to 5 squared. That's 5 times 5, which is 25 in this case. So we are going to obtain 25 here. All right, so that's 25 is equal to 25 plus 6 squared, which is 36, minus 2 times 5, that is 10, 10 times 6, which is 60. All right, if I'm not mistaken, there. That's 2 times 5, which is 10, then that one is 60. Yeah, that is 60. Okay, cos 40 degrees, we have got the value of cos 40 here, which is 0.77. So you substitute that, you multiply 0.77. All right, so that was it like this. Let's collect our terms. Before this, we have to add that part. Okay, so we're going to have x squared is equal to these two. They can be added together and they'll give us 61. So it's going to be 61 here minus these. We have to multiply them together. So that's 0.77 times 60 here. And it's going to give us something like 46.2. All right, it's going to give us 4,620 and 2 decimal places is going to give us 46.2 here. All right, so we're going to have 46.2. Okay, so subtract these two, 61 minus 46.2, that's 14.8. And this is going to give us 14.8. So x squared is equal to 14.8. And you introduce the square root both sides. So that's your x in set form. You can't simplify this. So it's going to be 14.8, just like that. So that is the distance that we're given. In set form means you have to just leave it under the square root. You can't simplify it further unless you can do so. This one, just leave it like that. All right. Number 25, we are now given that there are two similar bottles of height 8 centimeters and 16 centimeters. Take note, guys, the height gives us the scale factor. So 8 of S to 16, this is your scale factor or the ratio of size. So you can even reduce by 8, that is 1, S2 by 8 here, which is 2. So this is your scale factor here. So the question is, the bases of similar bottles that are similar are also similar. Okay, the bases of similar bottles are also similar. So the bases, they're also similar, which means the surface area of the base of the smaller one was given as 1.44 square centimeters. Find the surface area of the base of the bigger bottle. So in this case, we are given, what are we given here, guys? Take note, surface area. Here, these are the heights. So these heights, they only gave us the scale factor. So we have to find the area factor from there, the ratio of areas, okay, which is your area factor. And we know that area factor, you simply need to square your scale factor here. All right, so just square this value. We are going to obtain the ratio of areas now, which is 1:4. So this is the ratio that you are going to use for area. That is the smaller base has got area of 1 according to this scale that you are given. The smaller bottle here, which is the smaller bottle here, it has got a ratio of 1 and it has got an area. We are given its area, that its area is 1.44 square centimeters. What about the bigger bottle, which has got a ratio of 4? What is going to be the area now of that one? So which means the one with 4, we do not know its area in square centimeters. All right, so that means in this case, we are going to apply our knowledge here of finding this. This is going to be more. So as you can see, it's going to be what we are given here, which is this 4 here for the bigger one. the one that we want to calculate over this one that we are given, multiply by 1,44. Okay, so that was it, guys. And as you can see, this is just you and your multiplication. You are going to obtain something like 5,76 square centimeters. All right, so this is square centimeters. So like I said, guys, all right, so that's what you're going to have in this case as square centimeters because it's area. So take note, if you're dealing with area, you use the ratio of what? Of areas. If you are dealing with sides like this one, these were heights. It can be side, it can be perimeter, whatever that you give, as long it has to do with centimeters, you use this ratio of sides, which is the scale factor. But once you do it area, find area factor. Okay, which is the same thing now on this one when they're now saying find the volume of the, you see the volume. So this is volume, which means you need to find volume factor. All right, and we know that our volume factor is simply the scale factor that we are given to the exponent of 3. This is now volume factor, which is the ratio of volumes. And our scale factor is here 1:2. So you have to find the volume factor first. 1:2. All right, so this is 1:2 to the exponent of what? 3 to find our volume factor. So that's 1 to the exponent of 3. That's 1:1 times 1 times 1, 3 times. It's just 1. 2 to the power of 3, which is 8. Do not be mistaken. Yes, 2 times 2, which is 4, times 2, which is 8. So it means according to this volume factor that we are given, which is the ratio of volumes, 1 is representing the volume of the smaller container, which is the smaller bottle, the one that we do not know. So this one is representing the volume that we do not know. And this 8 is of the bigger one. As you can see, that's your bigger value, and is the one that we are given as 16. So 8, right? Now wants to take from that part now. Okay, so the 8 now is the one that we are given, and is given as 16 cubic centimeters. All right, so this is 16 cubic centimeters, like that. All right, so what does it mean? Since we want to find this one, as you can see, guys, this one is going to give us a lesser volume. So it's going to be 1/8 times 16 cubic centimeters. So the moment we multiply to 16 cubic centimeters, we are having the volume, which is 2. So we're going to obtain 2 cubic centimeters in this case. All right, so that was the volume of the smaller container in this case, which gave us 2 cubic centimeters from this one. So that's how you actually find or evaluate such typical questions. And it's very, very important that you understand what's happening there. All right, then let's see this one, 26. So 26, guys, there's no way here. I don't have the instruments that I can actually use. So to describe, but that one, if you are going to see, it was going to give us a rotation somewhere. There it was. Was it going to be a rotation? Yeah, this was going to be a rotation. I want you to try, because here these are congruent figures. And if you join the C here to the C1, I want you to see what is happening. The C to the C1, the A to the A1, the B to the B1, as you can see, C and C1, they cross each other, they cancel each other there, the B and the B, so which means that one was going to be a rotation. So remember how you do the rotation, you have to bisect the given side so that you can find your center of rotation and so forth and so forth. So you must make sure that you have got your center there, and you also have your angle there. Make sure that these are all there. So we shall try the best to have another software which can allow us to do those. Okay, then, but this one we can actually do it because it's direct here. Point A2 is the image of A under a translation. Find the translation vector. So we are given A2, which is the image. So A2, that's our image in this case, okay? This is our image, the image of what? Of A. So we are given A, which is the object. So A becomes our object. So what are we given in this case to find what? The translation vector, where we just need this translation vector to be the image minus the object point. So you just have to subtract the two like that. Or you can just even do it by movement. You can just move it. Okay, so what are we given? We are given the translation vector. We do not, okay, is the one that we want to calculate actually, which is the translation vector. So the translation vector is going to be the image now, which we said our A2 is the image, and our A2 is 1 minus 2. So that's 1 minus 2 here. That's our image minus the object, which is your A. Okay, so our A is there on the diagram. And our A is here, which is minus 1. That's minus 1, 1 there. Okay, minus 1, 1. Okay, so you take that point from the graph. So that was minus 1, 1. You write it as a vector like this, okay? So you can find your translation vector. That's 1 minus minus, which is a plus. So it's 1 plus 1, which is 2. Minus 2, minus 1, corresponding elements, minus 2 and minus 1, which is minus 3. All right, so this was going to give us minus 3 like this. Okay, so that was our translation vector, just like that. Yeah, and I think, yeah, it was just, yeah, it was fine like that. Okay, so like I said, guys, make sure that you just work on this one, find the actual graph that you're going to work on, because this was like, I don't know what happened, and this application does not have like all the instruments that I can actually use for those constructions and so forth, but I hope you understand from this part what is happening here. All right, so let's see the other part that we are given now. A velocity time graph, and as you can see, this is velocity in meters per second, and this is time in seconds. All right, so the first equation is calculate the total distance covered by the object during the 15 seconds. Okay, so this is during the 15 seconds here. As we know, guys, our distance is just area under the graph. So what you're going to do, you're going to choose either to work with this triangle here, rectangle here, and this triangle here, which means you're going to have 3 shapes, all right? Or you can just work with this shape here to be a trapezium, the whole of this part here to be a trapezium, and you work out with the last triangle. Okay, so I'm just going to use this as a trapezium and a last triangle, this one. Or you can choose this to be your trapezium, this one to be your trapezium here, and that one to be your triangle. So it depends, guys, with which one was best for you. Okay, so you just choose which one was best for you. Okay, so as for me, I'm just going to use this one. Okay, so I'm going to use this as my first trapezium here. And this one is my second shape, which is the second shape that I'm going to use. So remember that distance is simply the area, and area of a trapezium is half sum of the parallel sides times the perpendicular height in this case, and the sides that are parallel, we know them as A and B times the height, plus for a triangle, it's half base times perpendicular height. This is a right angle triangle. So that would be your distance. So in this case, the sides that are parallel, these are the sides that are parallel here. And this is our perpendicular height, this length from 0 to 10, that side. Okay, so that's it, guys. As you can see, okay, let me just remove this part. All right, so that means in this case, we are going to have half of the sides which are parallel. We have got 90 here, the whole of that line, that is 90, plus the whole of this line, which corresponds here at 60, so it's 60, times the height. The height in this case is from 0 to 10. So that would be a 10 there. Okay, so I'm done with the parallel, the trapezium. Let's move on to the right angle triangle, which is half base times height. This is my base from 10 to 15. So it's going to be 5. 15 minus 10, which is 5. So it's going to be half of 5 times the height, which is, this is our height here, the height now of the triangle, which is 60. So that's it. That's our perpendicular, just like that. So we can actually work out here 90 plus 60, which is something like 150. All right, so we've got 150 here. And we can actually reduce this if you have to cross-check by 2. 2 to 150, which is 75. And if you multiply 75 times 10, that's 750. Yeah, 75 times 10, which is 750 plus. We can reduce 2 here into 60, which is actually 30, and 30 times 5, which is 150. So that is 150 here. So you can add 850, means 750 plus 150, that's to be 900. Yeah, 800 plus another 100 is to be 900 meters. Okay, so this is distance, which is measured in meters. All right, so that was it, guys. For this distance, we obtained 900 meters there. All right, then let's see the other question, which is the average velocity during the 15 seconds. So 15 seconds, that is where we had the whole gen. As you can see, this is the last time that we have, and we know that velocity, average velocity simply means distance over time. So that one is simply distance over time. So what are you going to do? We just have to divide in this case. All right, that's our distance divided by the time, like this. That's our average velocity, and the distance is the one that we got. We got 900 meters over the time. The time is 15 seconds. So we're going to divide by 15 seconds. All right, so 15 into 90, that is 6 into 0, that's 0. So it's going to be meters per second. Remember, velocity is just average speed. So it can be average velocity, average speed. It's one and the same thing, distance over time. All right. Then the deceleration of the object during the last 5 seconds. Okay, where do we have the last 5 seconds? Here. This is where we've got our last 5 seconds here. From 10 to 15, we've got 5 seconds here. And remember that deceleration is equivalent to what? To the negative of the acceleration that you're going to get. In this case, that would be your deceleration, which is just negative acceleration. So all we need is to find the acceleration for that particular moment, which we know that is the change in velocity over the change in time. That is the change in speed over the change in time in that case. Okay, so in this case, we are going to have our change in velocity. Let's see, as you can see, it's a decrease that happened. And our final velocity in this case is at 0 here, where it is at final. At this point, 15 here corresponds with a velocity at 0. And from this point of 10 seconds here, at this point, it corresponds with a velocity of 60. All right, so that is actually what you are given in this case. This corresponds with what? With 60 here. Let me remove so that, okay, that's a 60. So what are you going to have? We are going to have 0 minus 60 here. Okay, so that's 0 minus 60. Okay, that's our change in velocity. So that's going to be 0 minus 60 over the change in time. So what will be the change in time? That is over the last 5 seconds. So the time is still 5 seconds, like that. Okay, so 0 minus 60, that's a negative 60 over 5. And this is going to give us negative 12. So the negative 12 meters per square second, remember the units, that is our acceleration in this case. Therefore, the deceleration that you're going to have is going to be negative times that acceleration that we got, which is negative 12 in this case. And if you multiply, this will give us a positive. So it's going to be positive, because now you are having the exact thing that is happening, which is the deceleration. So to be a positive 12 meters per square second. So that would be your deceleration in this case. So as you can see, that's how you actually attempt these typical questions. All right, so let's see. Okay. This is now the paper 2. Okay, it's fine. So that's actually what we had from this paper, guys, June 2019, paper 1. As you can see, it's yeah, it was just a fair paper. Yeah, it was nothing much difficult. It was an application. It was that paper that you need to apply the concept. Okay. Yeah, no, the calculations, they are fair. I don't know. Let's know. Let us know how did you see this part? So let me actually know what happened there. And guys, do not forget to share our platform to your friends and colleagues. That is the major thing that we actually need. Let everyone have access to learning like what you are doing, guys. So the only thing that you can help us with is for you to also update your other colleagues, that they can also learn with us from this platform. Okay, so let us continue to do the good job that we are doing. Share our platform, share our videos to your friends and colleagues. Yeah, someone needs this information somewhere, somehow there. Someone needs this information. So please do not stay with this information alone. Make sure that you share to your colleagues. Yeah, but as you can see, guys, this was actually a fair paper that we had. Okay, so that's it, guys, from Maths on African Motives, working on O-level maths. Till we meet again.